Good morning, ladies and gentlemen, and thanks for being here so early. We are coming to our conclusive day of this exciting GLEX 2025 conference, and I welcome you very much here in the room. We've seen already 2 exciting days of exciting presentations, panel discussions, and we are very happy that you are also from the audience engaging very strongly with the speakers. Perfect. We will kick off today's program with a highlight lecture titled Space Exploration to Benefit Humanity on Earth, and it is my distinct pleasure to call on stage Dr. B.N. Suresh, Chancellor of the Indian Institute of Space Science and Technology at the Indian Space Research Organization, ISRO. Dr. Suresh, please, the floor is yours.
Good morning. Thank you very much for this excellent opportunity to discuss one of the important topics of space exploration to benefit the humanity on Earth. It's a very, very vast area, and I've been given half an hour. Hopefully, I should be able to do justice, trying to tell you what we are going to do. On the screen, what you see is, as far as the space exploration is concerned, one of the greatest instruments that you have put in orbit. All of you know that. I've just brought it, the kind of exploration that is going on and the technology developments that are happening in the globe. I thought this is just one true representative of the bringing one of the sophisticated instruments to really explore as much as we can. And of course, the other details you will see on the screen in terms of the launch date, this cost. Of course, it was started with very low cost, but at some point of time, the cost has to go up. I'll come to that a little later. And already, I think it has given enough and more. Before that, the Hubble telescope was there. That also has helped us vastly in exploring many things and then increasing our knowledge in several areas. This, I think all of us know that, today there are very few spacefaring countries who have really mastered the exploration in terms of different fields. When we talk about humanity and helping them, I think what is important is how we are able to really help the common man all over the globe, not just only spacefaring countries like who have the capability, maybe elite 5 or 6 countries. But then I think the whole idea behind that is we should reach out and then try to help the whole humanity, and the level of living and those things have to improve. And you can see that I will not go into the circle, whatever is shown. I'm sure you are all familiar with that. But what is important is it's not complete by itself. It's only representative. Otherwise, today, you name any particular domain that is serviced by space in some form or other. That's why what you see on the left corner, outer space for humankind, but touching every domain needed by humans. I think this is where our ingenuity of all explorers, technologists, scientists, where you can think and then utilize. And particularly, I would like to say that today, not only in helping various technology areas, but then try to bring it into the governance. I think you would have heard last 2 days, I also heard how the space is being utilized very widely, very extensively for governance. I think that makes our life simpler, accurate, and also able to reach out to the people as quick as we can. And right on top, you can see that understanding the universe better, I think so many centuries have gone, so much of effort we have put in, but then I think a lot more we need to learn. This is where we must do that. But what is extremely important is look at the inner circle, that today the space exploration is able to really contribute very crucially to meet the sustainable development goals defined by UN. I think 17 of such them have been given. There are something like 160 plus work packages. In fact, each one of them today, space is able to address that and then bring the needed results. But what's most attractive is no other technology, no other exploration in the globe has inspired or attracted the younger generation. Particularly, wherever you go, the moment they hear the space activity, space exploration, the youngsters, they get excited. In fact, this is one of the very important contributions, in my opinion, where the technologies, science, and exploration have brought in the interest of the younger generation. That is very, very important. Now, let us just take a look at okay, now if we really look at what is important is how really the impediments which have happened in the country or all over the globe for space exploration. In my opinion, this is very important because we may have ambitions of doing many things, helping in several instruments, other things. But then there are two important factors. That is essentially what we call as significant impact on schedule, cost, and volume. These things happens because there is a restriction of taking anything into the space in terms of mass and volume. And I just mentioned right in the beginning, James Webb Telescope is one very good example. I'm sure some of you would know that the initial estimates were something like 550 million in 1997, and it really went to 10 billion. This is just to tell you the kind of complexity involved, the kind of cost, kind of efforts that are involved in space exploration. And important thing that we need to remember is that essentially in all space arena, what is very difficult, what is very complex is trying to control the mass, volume. These are the things that really brings, and when these constraints come, you cannot cut down the performance, but then it's important for you to really meet the requirement, and in the process you increase the cost, and these things happen. What are the crucial aspects of outer space for humankind? Of course, it has to be an open exploration, and the important factor is utilization should be by all countries. I think that is the underlying principle, no matter where you are, whether in Africa, whether in South America or elsewhere. How do we really distribute the benefits to everyone in a proper manner? Then definitely should provide the benefit no matter where you are, what you do. In terms of each one of them we have told, and it's happening today, in terms of providing the satellite, providing the ground system, providing the application program so that they are able to utilize for their own, for improving the level and life of human beings. And of course, while we talk about exploration, it also includes the moon and celestial bodies. And underlying principle is we must use it only for peaceful uses. I think that's very important. But then there are certain important aspects which are given is that the states are responsible for national space activity, whether it's governmental, non-governmental. I think people should understand that. That is extremely important. Also, they are liable for damages, if any, caused by on the space objects. So, in a nutshell, why space exploration for all? I think that is the theme on which we need to work. If we do that, it becomes very important. The first and fundamental thing is how do we really enable the scientific advancements in a calibrated manner to benefit each and everyone. It's not that we are trying to compete with one another, but then we need to build the scientific advancement depending on our requirement and need. And today, I think last 2 days, I have heard the kind of economic opportunities that this creates space exploration is something phenomenal. I'll come to that a little later. And as already mentioned, I think this keeps the interests of our youth alive. More than anything, if you really look at the kind of technologies which have come and gone of different sectors, different space is the one which really has triggered the innovation to the maximum extent, not only for benefit of space themselves, in other common areas also. Of course, another thing is, really if you look at the kind of international cooperation which has emerged, which also has been discussed at great length in the last 2 days, is the space exploration. Of course, this must be known to everyone, but then for the benefit of people who do not know, I would like to mention this. What is important is, our entire governance is sort of regulated by the treaty which was done in 10th October 1967. It is 58 years ago. Until today, I think it's being followed, and this dictum is taken very seriously. There are sort of 4 important aspects which have come out of that. Is that it acts as a foundational pillar for all multilateral space government. I think it is extremely important for all of us to know. And it's an international agreement, as I already mentioned, for the peaceful use of space and exploration. And I think nuclear weapons, it is prohibited, but then we keep hearing now and then, no, it's our national interest, we would grow. But I think if you really consider the humanity at large and long-term perspective, one has to really debate and then see that that doesn't happen. Then, of course, no provision for claiming the sovereignty by any nation over celestial bodies. This is something very important. Now, the next slide is the one really to tell you, it's not to say that we launched so many. This is just to tell you in one slide how the space exploration has increased tremendously. It just gives only the launches by year, starting from the very beginning, 1957 to as late as 2024. What you see somewhere in between, you will see a slight peak. That was the era of Cold War, and you all know that there was a very, very fierce competition between 2 great nations, and but then it came down, focus shifted to really how to help the common man, how to really utilize our efforts towards benefiting the common man in terms of agriculture, in terms of fishing, in terms of many other things. But what I would like to mention is, you take the last 4 or 5 years, there is a tremendous surge in launches. What does it mean? It only means the efforts on the space exploration has increased tremendously, and already you can see the nature of the curve is almost exponential. And on the left side I have given that it was 2023, it was 223 orbital launches, but then 2024 you see it's 262. There's again quantum jump, and out of which you can see that almost 145 launches have happened by SpaceX alone. I'm bringing this point essentially to drive home that the kind of private agencies coming and getting into the picture, you can see that it has a multiplier effect, and the efforts on space exploration has increased. And when you have so much of increase in the space exploration, the benefit that you are going to derive also will be substantially higher. And how do we do that? See, this is a very interesting thing, that if you really look at the evolution of air travel, space exploration, one thing is certain. On the left side, you will see the air travel, and what you see on the blue curve is essentially how many passengers they can carry over a period, and the green curve, what you see is how the cost of travel has come down. This essentially means any such very, very expensive ventures you do, it is important for you to be sensitive on the cost aspect. On the right, what you see is, it is extremely important for us, starting first one is the space shuttle, and you see the curve, what you give is as a function of time, the year, the cost, how it is coming down. And I think all that colored lines, what you see, is the one where we are, and last one is SpaceX, where it has really brought down considerably the cost per kg for launching. Because, every country we discussed yesterday and day before yesterday, how expensive it is. Only few countries who have the finance can do that. But then I think it's important for us, in order to really distribute our benefits to everyone, we must enable, we must develop the technology to bring down the cost. That is extremely important. That's the message I wanted to give. Now I think I mentioned to you about how it is integrated into helping the sustainable development goals. In my opinion, I think the space is one of the greatest contributor helping the sustainable development goals. What is required is that has really driven us in terms of enhancing the space technologies as well as the generation of the data. That is very important. What kind of data you need to generate, what kind of payloads you need to develop, what kind of the transfer of the data from there to Earth, and then transforming them into useful data for everyone to look at it, particularly people who govern various activities. So that is extremely important, but all these things should be addressed towards taking the challenges on Earth. I think unless we link all these activities and development to challenges on Earth, be it agriculture, be it forestry, be it the ocean, be it weather, anything that you take, you have to link with that. And then you have to really bring down the costs on one side, develop the payloads on the other side, and take it further. Then, of course, we have seen there is a progressive leap. I'm using the word leap because it is just jumping one to another in terms of resource survey, disaster management. You can see the kind of support that it can give in the present day is something very important. Environmental changes. I think this is the one area that is being talked when we talk about the sustainable development, protecting the earth, protecting the humankind is something very important. Then, of course, our scientific understanding, how it's really getting enhanced. Then, of course, while we worry about the environmental changes, we have to worry about the environment, the space itself costs, particularly the kind of launches that we bring and then the kind of debris it creates, that also we have discussed. And I think I have just given a sample, some of them. For example, environment and climate, which is extremely important for the entire world, and we talk about the global warming, we talk about the future generation, and the kind of the vagaries that environment is causing today is fantastic. So that's where you can see that the systematic monitoring of the environmental changes, advances in technologies for better understanding of climate, so on and so forth. In fact, it's all listed there. This is where you can see that every area so much efforts have gone. And this is where one has to really see it is not just only the space and technology people. I think scientists come in a big way in terms of understanding the problem, in terms of defining the problem, in terms of developing the instrument and trying to put them together. And you can see the disaster management. Again, today I think it has really become so very simple in many of the countries, but then this facility is just not available in many other. I think that's where the UN has taken a very, very great initiative, trying to put together and trying to synergize our efforts. Agriculture, I think this is one area where today a lot of efforts have gone in terms of the crop yields, in terms of irrigation practices, water assessment and precision. This is where Israel has done very well, and in fact, people are trying to borrow from them and then see how we can really enhance our. So also on education. One can go on and on. I think just I wanted to give you an idea. And while we do that, it's important for space people to worry about disruptive innovations. I think unless we look at this kind of disruptive innovation, one breath you say you are trying to reduce the cost, another breath say you say that you are going to enhance the launches, third is I'm going to provide more and more space services to the humanity. How do you really do that? I will not get into the details. I'm sure that you are all very familiar with that. The efforts which have gone very well. In fact, on the right side top, what you see, all engines and all that. If you really look at it, I think I mentioned right in the beginning, the efforts are in terms of how do I bring down the mass to enhance the performance, to give much better result. Then how do I enhance the thrust for the same mass these are the technology innovation that is required, and today it is happening all over the globe, particularly spacefaring nations. And I think if someone really wants to initiate the space development, I think they will have to keep these backgrounds into their mind and then take. That's how you can see that, for example, booster stage recovery, what SpaceX has done. I think it's amazing. All of you know that the kind of innovation which has gone, and that fellow comes and in the launch pad able to really arrest it with very least effort, almost hugging the spent stage coming back. It is something very important. Now, what is important, you can see that at the same time, the developments which have undergone, some samples are given, and again not to scale because then it's difficult to put them together. You can see that what's happening in US, what is happening in Russia, what's happening in France, and what's happening, and what you see in the loss. I think our friends have already brought out what is that we are trying to do as the new generation launch vehicle, where we enhance the capability, bring down the cost, and able to sort of go further in exploration. I think these are the things that we need to do really. Now comes what is that we are doing to the society. I think that's extremely important. When we talk about humanity, we talk about technology, we talk about the cost, we talk about putting together, but then the common man on the street would like to ask a question to the space community. What is that you are doing for us? This is the question our Vikram Sarabhai told right in the beginning when Indian space program was started way back in 1959-60. I think it was very difficult for him to convince the government at that point of time. He said, I'm going to improve the life of the common man in the country. That is the statement made. And today, if you really look at, apart from providing the services in host of areas, I think it has also brought out, I think many of you are aware, the spin-off technologies it has brought in a wide variety of areas. I don't have time to really discuss some of them, but then it has done great deal of services to the medicine, energy, communication, and if you really look at it, many things which have gone in a big way, be it material, be it some kind of instruments, be it some kind of services, all of them have gone. Then, of course, while all these things we do, I think we discussed yesterday or day before day on space debris, and I think this is something very, very serious issue. All spacefaring nations have to worry about it, and it, in fact, is a threat to the future space mission. It may not happen every now and then, but when it happens, and you have a very beautiful instrument put in the sky, you are in serious trouble actually. So that will create. And of course, I already mentioned how do we really try to reduce the pollution. But I think another important factor which has attracted the attention is, I think if you really look at the natural resources which is available on Earth is getting depleted, whereas population is increasing. How do we really bridge this gap? I think that's where you need to really worry about. I think there are enough evidence, enough data available that resources that are available in the planets, other planets, the asteroids, comets, etc. That's one of the reasons you see that certain explorations have been done by Japan, US, and Europe, and then they are able to really reach. It's very difficult because a very small piece of volume and space, you are able to go there precisely, then try to extract the information, then try to extract and bring it back. It's all easier said than done. But then question is, it's all going to happen. Today's fiction is tomorrow's science, tomorrow's technology. I think we must remember that. And of course, already I mentioned international cooperation is something very, very vital. Without that, we will not be able to make any progress. It's important for all of us to do that. Then, of course, one important factor I would like to do is, space is an expensive business, risky business, costly business. But then, how do we really take public into our fold? I think this is some area we need to, this is where sociology comes, social sciences. How do we really integrate the requirements of the public in doing such advanced technology and once you are able to communicate and tell them that this is what I'm going to do, this is how you are going to help you, then it becomes very, very important. Now, of course, as I mentioned earlier, that the cost is something important. We were discussing many things for a long time to come, but today I think focus has shifted from the various technological development, the services that you provide, the help that you can provide. But look at the national economy. And so the one what you see down below, I think as on today, of course, this is all known data you will have, but then I would like to do, on top what you have done is, till we sort of geared up ourselves, put it in the first gear as far as the space activities are concerned. On the top, on the right side, you can see that. And on the left, how it was. You know, initial days, it was all the government support. And only very few activities, they were sort of being done by commercial, like communication, Earth observation, and also some parts of the space exploration. But then today, I think it has really moved to the entire private firms, public companies, and government, in fact, is trying to concentrate only on space science. I don't think you can expect any private operator or industries to concentrate on the space science development because cost is very high, or human space flight, for the very reason that the reliability and quality that you need to maintain and the infrastructure that is required is tremendously great. And of course, any technology demonstration for future, no public companies will venture into that. So 447 billion which is there by 2047, of course we have taken 2047 for the simple reason, this is our centenary year of our independence. You can see that it really multiplies more than 3.5 times. And our ambition at India, what is shown in red down below, 2024 to 2030, from 2% where we are today, I think it's again being projected. Nevertheless, I would like to repeat that. I think why youngsters, they look at space. One is, of course, their own interest in innovation and taking it further. Second is really how to generate the economy and improve the nation's economy. That is extremely important. And of course, while we do, I also would like to mention that it is important for us to have some kind of guidelines for all the space exploration and to keep it healthy. One is, of course, it's important for everybody to kind of keep the economic and comprehensive database. Not only you keep it, I think you have to make it known to all stakeholders. Here stakeholders are not only the scientists, technologists, policymakers, the general public, all of them you have to take and then keep it transparent. I think once you keep it transparent, you will get the support, because without support you are not able to progress, and without public support you will not be able to get the finance, and you cannot really excite the youngsters to take up the projects. And what yesterday our Vinod was mentioning in terms of the startup companies, once we brought this awareness, you can see the multiplication of that. That in turn will link with the economy. That in turn will bring the welfare of the country, welfare of the people. That is extremely important. Then, of course, it's also important that the decision makers are not just only stakeholders. Stakeholders are important to make a critical decision, but then it is also important for us to really bring all stakeholders to some extent, even in public, in decision-making process. That only gives you effective governance. In fact, if you really look at it, the people who have succeeded, who are able to do very strong space program, although it is very difficult, because here, it's a two-edged sword. Because one place we derive advantage, another place you have to really spend a lot of money, a lot of risk, a lot of accidents happen. But then how do you really keep the activity going in a smoothless and continuous manner? It's extremely important. Then, of course, they also generates a lot of contamination, because we are dealing with the propellants, chemicals, and many other things, and explosions. All these things do happen, and we have our own experience on various things. It could be biological, it could be physical, it could be chemical contamination, but we need to address all that, of course. And of course, all that scientific discoveries and advancements we do in the research and space exploration have to be related to the policy and regulation. If you don't do that, if you don't put a policy in place, no amount of development, no amount of effort will reach out what was. Because that's why everywhere, I think, our people also, they talked yesterday, I think Vinod himself brought the kind of policy that they have put in space in the recent past, that helped for people to look at this exploration. So these are some of the things that we need to worry and bring out some kind of very effective coordination between stakeholders. I think that's extremely important. Now, what is another area is, while we do all these various assistance to the common man, I think scientists are equally interested because there is many, many unknown. I think there are a set of people, particularly in the science arena, who are interested. And it is a very long list. What I have shown is not just the end of that, but then some of them, like cosmic microwave background, accelerating expansion of the universe. I think that is something is being talked, but then if you ask a question how exactly it happens, I don't think we have a right answer. And exoplanets, I think it is really being dealt very, very extensively and able to find newer and newer things. So we can go on and on. I will not dwell on that full length, but then fundamental questions, I think we are yet to get an answer in terms of how did the universe form, what are the laws of nature on extreme scales, are we alone or life exists elsewhere. I think, every now and then something is being flashed here and there, tons and tons of money is being spent, but then we are yet to answer these things. Of course, this is all known. Just to tell you, I will not dwell here very quickly, but then each of the science mission, what it gives in terms of knowledge increase and the users that are there, on each one of them you can see that is all shown. Chandrayaan-1, Mars Orbiter mission, Astrosat, Chandrayaan, our own program, and down below you can see in terms of publication, in terms of users, and in terms of new findings. It's not complete in all respects, but then couple of them I have brought it so that people will understand why we should really do the exploration. And of course, we have to continue further. That depends on the policies, that depends on the nation, and then trying to put together. You can see here in Lunar Lander and Rover, what it has done, Aditya L1, what it has done, and of course, ExpoSat, what is that we are trying to do. You can see the down below, whatever is shown in the box, is we are trying to enhance the knowledge base. That is what is important. Then, of course, another important area that one must be concentrating when we talk about space is the microgravity experiments, and this is where, starting from International Space Station, tremendous amount of work has gone in, and lot of knowledge base has been increased. And some of them, what you can see here is basically in terms of the creation of materials, improvements in the drug, so on and so forth. You can see the combustion itself. See the one what you see here, how the combustion flame will look like on Earth and how it will look like on space. These are all these tremendous advantages one derives if you are able to go to space, and that's where they have done tremendous amount of research, and I think we should concentrate there. This is just to tell you one simple example of the studies on metallurgy. I am sure I will not bore you getting into the details, but what is important is, there are many aspects of metallurgy which is fundamental. Any technology you take today, the metallurgy and mechanical engineering, they are the base. Without that, you will not be able to make any big progress. And if you ask me frankly, there are only two technologies which are governing all advanced technology, particularly space. That is, one is propulsion, second is metallurgy. These are the two areas. That's one of the reasons I think metallurgy expansion. And what you see on the right is how the bowl will be look on Earth, and you don't need a bowl when you go into the space because that liquid, whatever is there, it will create a bowl itself. In that case, the experiments you do will not have any contamination, and you will come out with the really path-breaking results. Of course, this is the last slide. I would like to mention here that, some thoughts to ponder over. This is extremely important. When we talk about the exotic ideas and exotic areas, it becomes very important for us to understand. For example, way back when the commercial flight happened during the World War II, people were wondering what will happen, and today I think you can see the whole sky is really cluttered. If you really look at the photo they take at any given point of time, it's amazing. Same thing happened with the IT, and when it started with just simple computer and all that. Today I think wherever I go, people, it's very difficult to talk to them because they are immersed in their mobile, because whole world is with them. That's what really happens. So I think I would like to mention that we still are in a very infant stage as far as the helping the common man is concerned. Maybe as a spacefaring countries who are advanced, maybe serving themselves, but then for the people who are elsewhere, who don't have access, who are depending on others, I think we have to give that helping hand and make sure they are with us, they are able to reap the benefits of that. I think that is extremely important. And like what happened in aircraft, what happened in IT, many other fields, it is going to happen in space. I think it becomes maybe 10 years down the line or 15 years down the line. The man on Earth cannot live without the assistance of the space. I think that is what is important. And we have to make sure that we reach out all these benefits to everyone, distribute ourselves. But then question is, are we prepared to be part of this history? And I think we all, as spacefaring nations and space community, ensure that that happens while we talk on many things. With that, I come to the end. Thank you very much.
Thank you very much, Dr. Suresh, for this very interesting presentation. And now we'll immediately dive in the first and conclusive plenary, actually, of this conference, which is focusing on and is titled Outer Space Exploration for All. And it's my distinct pleasure to call on stage the moderator of this plenary, Mr. Rakesh Sharma, Director Technical of the Indian National Space Promotion and Authorization Center in Space. Mr. Chiotti, please join me in a round of applause for him. The stage is yours.
Very good morning, all the ladies and gentlemen. I think we had just got the insight of exploration, the need of that, and what benefits it gives today in this scenario by none other than the veteran Dr. Suresh. So now we are going to, I welcome you all in this plenary session, Outer Space Exploration for All. The theme of this session resonates with the theme of, or the objective of this particular conference, as it captures the two things, the global as well as the spirit of shared space exploration. Both things are very important. So if I'll just give you, before we have a very interactive discussion of the panel, I just want to give you the basic issue which is there. If you look back historically, then we see that outer space exploration has happened only because of two things. One is because of fostering innovations, another is the collaboration in the space sector. A lot of success stories have been in place. We have seen over the last many years. We have seen the first one was International Space Station, which demonstrated the multinational effort involving NASA, Roscosmos, ESA, JAXA, and CSA, which has served as a hub of scientific research and technology development. Many planetary missions have been seen, like deep space missions, and also, as Dr. Suresh was mentioning about the James Webb Infrared Telescope, the Colombo, the Cassini hygiene, all these are demonstration of joint missions. But what next now? How we see that next decade is going to push the boundaries of space for the benefit of human. Currently, if you see, there is a paradigm shift that is from space 3.0 to the space 4.0, which implies the introduction of new space sectors, that is commercialization of space sector. We are talking about economics. We are talking about global collaboration. We are talking about technological innovations. The new innovative services have started coming, and associated risk or the regulatory framework for safety and security of the system. Currently, we are going to have, in the next decade, ISS is getting transformed into a commercial space station by Axiom. SpaceX is building its own Starship for fully reusable rocket for interplanetary travel, for space exploration. Blue Origin is talking about the new services for the space tourism. 54 countries have signed Artemis Accord for Mars and for the lunar exploration. India also has joined this. It was the 27th country which signed this Artemis Accord. ISRO and JAXA is working on various next Chandrayaan sample return mission and many more. In short, the new technologies, the new commercial actors are giving momentum to the exploration for both scientific and socio-economic benefit. Ladies and gentlemen, we have a very distinguished leaders from different space organizations in our panel. This panel will explore how advancement of these technologies and innovations and commercialization and international collaborations are going to make space accessible to all. I will urge all these delegates who are sitting here in the audience to imagine their role in this shared future and be part of this panel by asking questions. Let me invite all the panelists and give their biodata one by one. I would like to invite Dr. Abdullah Ahmed, who is the head of strategy research from UAE Space Agency. I think due to some reason he is not available here. Okay, so we have with us Henry from Rwanda Space Agency. I invite Henry, she is an international cooperation analyst. She is a resourceful and self-motivated international development professional with extensive experience in the strategic partnership event management. At Rwanda Space Agency, she plays a pivotal role in fostering international collaboration and promoting the use of space technology. Welcome, ma'am. Next panel, I would like to invite Eric from European Space Agency, Director of Europe Legal and International Matters. He is associated with the ESA since 1987, and currently he is the Deputy Director of Industry, Procurement and Legal Services. He was also appointed as a head of ESA headquarters in October 2016. Thank you, Dr. Reed. Next, our panelist is Bob from Luxembourg Space Agency. Please. He is also lead for exploration and space resource strategic advisor, lead for exploration and space resources, and in European Space Resource Innovation Center called ESRIC. He is currently the senior manager at the Luxembourg Space Agency, where he supports the development of commercial space industry. Welcome, Bob. The next one, I would like to invite Etienne Sebi, our astronaut from Rakia mission, who has been there as the first astronaut in the first mission of Axiom. First mission, commercial astronaut, and he is doing a lot of activities on humanitarian objective and economic stability. He is a philanthropist, he is a businessman, and who is venturing into space business. I think I was told that Unikrishan Nair is not able to join, so in the morning I was mentioned that Victor Joseph is going to be there. I invite Victor Joseph, who is having a more than 35-year experience in Indian Space Research Organization in the space transportation system. He is currently having a role of Human Space Program and the mission director of launch LVM-3. Welcome, Unikrishan. Welcome, Victor Joseph. And I'd like to invite Lisa Vitres, Director of IAC Sydney, Space Industry Association of Australia. She is Director of IAC Sydney 2025 at the Space Industry Association at Australia. She is an experienced business leader with experience in high growth acquisition and digital technology and branding. She has many things stored for the next IAC also in Australia. Thank you, Lisa. So now, before I want to welcome all the distinguished panelists here on the dais. And before I hear your views on outer space exploration, I will ask each of one of you to bring to the audience the current status and the brief plan of your space exploration. So I'll first invite Henry from Rwanda Space Agency.
Good morning, everyone. I'm going to talk about Rwanda Space Agency journey. Rwanda Space Agency is a government institution that was recently established. That was in 2020. But before establishing the space agency, we had a small working group that was working under our regulatory body called RURA. And during then, we successfully launched our first satellite in 2019, together with our international partners. And then from there, the government really realized the need of creating a space agency. So that's when, in 2020, the space agency was created. After the creation of the space agency, Rwanda really played a vital role in using space for socio-economic development, because that's the actual mission of the space agency. And from there, we have been doing a lot of things, and we have achieved a lot along the way for the past 5 years. According to WTA, there is still a gap on the sub-Saharan African continent on the infrastructure of space sector. And that's when Rwanda Space Agency really saw a need in having our first teleport. So Rwanda right now has a teleport that is a 9.3 meter. And that antenna, what it's doing in Rwanda, it's helping in different sectors to inform some of the decisions that we are making as the government of Rwanda. So as Rwanda Space Agency, we are focusing on both upstream and downstream. On the downstream, we are focusing mainly on the developing good space applications that are helping in different sectors like agriculture, urban planning, disaster management, and so many more. And then when it comes to satellite communication, there's still a huge gap in some of our rural areas that don't have good internet connectivity. And we opted for satellite internet to really cover some of the areas that are not covered with the broadband internet. And I can say by now we are at a good stage where all the country is going to be soon connected with the internet. And lastly, we believe that for all this to work, there should be good policies, good regulations that not only facilitate or work for the government of Rwanda, but also private sector. So recently, we had our policy and the 10-year strategy approved. So I can say that by the time we are having investors in Rwanda, we believe with the policies that we have put in place, it will facilitate them with having their private companies have their operations in Rwanda. And all I can say is that space technology being relatively new on the African continent, it's really hard to oversee the need for skills development. So as Rwandan government, what we are trying to do now, we are trying to bring in space-related courses on for our universities, which was not there before. And we believe that with what we are doing for the universities to really shape the skills for the next generation that we look forward to working with in future. Basically, that's our journey. And as he mentioned, we are also part of the global conversations because we want to be on the tables that make decisions. We recently signed the Artemis Accords. I think Rwanda, together with Nigeria, was the first African country to sign the Artemis Accords. We are also really honored to be also members of the IAF and proudly hosting GLEX, as he mentioned, next year. And I take this chance to welcome everyone in the room to Kigali, Rwanda, to really have a sense of what the Africa is doing. So basically, that's in brief about Rwanda Space Agency.
Thank you, Andres. I think give a clearly the insight of how you are now utilizing the space for your African region as the application. So I'll request now Eric, to Director of European Legal and International Matters, to tell us what activities are being done currently in the space exploration under your leadership.
First, I would like to say that I'm first a good morning to all, and that ESA is really happy to be present here in India at a moment where we are reinforcing our links with India. But I would like to show to you this first image, because that is showing what is cooperation. ESA is the tool used by 22 countries in Europe to cooperate together. The table you have there in front of you is the table of the ministerial meeting of 2022. This is where, around this table, that the budget of ESA for the years 23, 24, 25, this year, have been decided. And you see the difference. You don't have a small committee or a prime minister deciding. You have a table where you have 22 member states cooperating together. And the message of this image is the following. What we can do together at 22, none of the 22 countries could do that alone. So that is the first image of cooperation. If you can move to the next one. That is the second image. The ESA Science Program is something absolutely unique as a way to cooperate. ESA is offering through the scientific program to the 22 member states and to the scientific community missions. ESA is providing the satellite bus, is providing the launch, is providing the operations, but the member states and their scientists are each of them providing the payloads. And this is a program that is managed by the scientists for the scientists, and it's a unique example of cooperation. Again, all the missions you see there on this graph, none of those missions could have been undertaken by one single of our 22 member states. This is a second image of what cooperation is. And the third image that is coming is the ISS program. In the ISS, you have 15 participating states. 11 of those 15 participating states are represented by ESA, 11 European countries. And here again, this is maybe the example of international cooperation that is quite covering decades of cooperation among a number of nations. And here again, you see how much an agency regrouping, a regional agency regrouping 22 member states can bring to them the possibility individually to benefit from a program like ISS because they join together. So you see, this is the image I was willing to give, that cooperation is really the center of the DNA of space in Europe.
Okay. Thank you, Eric. I think so the message is that you already have internally 22 countries aligning internally within Europe to go for various missions of space exploration. Okay, thank you. So I'll over to Bob. You can tell us what you are currently as a European Space Resource Innovation Center, how you are seeing the space exploration which is happening through Luxembourg.
Sure, thank you. Good morning to everyone. First, I have prepared one slide on Luxembourg and the activities in space in Luxembourg to provide some background. So it all started in 1985 with the creation of SES, which in the meantime is in the process of acquiring Intelsat and become one of the largest or the largest satellite operator. And they also recently opened an office here in India. Then it took 20 years before the government decided to join ESA, become the 17th member state of ESA. The idea here was to develop the space industry beyond satellite communication and also support the European effort in developing space. Then in 2016, the government launched the Space Resource.lu initiative. We get back on that in 2 more slides a bit later. There was a very forward-looking initiatives to create a framework to use space resources. In 2018, we created the Luxembourg Space Agency and had a short revision on our strategy in 2022. On the next slide, you see a bit the mission of the Luxembourg Space Agency. Can we move to the next slide? Yeah. So we see our role more as an enabler, and maybe it would be more accurate to say we are a space development agency, and we do not have our own space missions, our own space technology roadmaps that we drive. But we believe in the future of space, of commercial space. We see a big opportunity to diversify our national industry and economy through space, and we help industry innovate and create the products and services in space, for space, or from space, or using data from space, and so on. So on this slide, you see a bit our mission is to drive the economic growth, create jobs, help local industry to innovate. We do this through our national space program, but also through the various programs at the European Space Agency. We also help train talents, the talent that the industry needs, and we engage internationally to find the right collaboration for our industry to partner in different programs. And then the last part of the introduction I want to share is on the next slide. There's the Space Resources.lu initiative. That's an initiative we launched in 2016, which addresses. Maybe can we move to the next slide? There's one more slide. Yeah. So the initiative says that Luxembourg aims to contribute to the peaceful exploration and sustainable utilization of space resources for the benefit of humankind. And so this is it's a very broad initiative. It's important to understand it's not a mission or a program itself. It's a rather broad initiative by the government at various levels in different ministries to create a framework where commercial operators can actually operate and use space resources. And this comes with many different challenges. There's the regulatory challenge, which is a big one, an important one, where we are very active at COPUOS to drive the discussion on this, to come to a common understanding altogether on what this means, or how, or what are the principles which allow utilization of space resources. We also have a national law to put forward our view on it. I think this clearly underlines the importance of that Luxembourg brings to this topic. But we also develop technology with industry. We help them find investors and fund those developments. And we recently created the European Space Resource Innovation Center, which is a bit a public center dedicated to space resources, to drive this topic from a scientific point of view in the long term. Thank you.
Thank you, Bob. I think now, Etienne, you have to give the perspective of both Astronaut and as a business in Israel, how your private and public applications have been considered. Over to you.
Thank you, Rajiv. I'm here because I wish to use the clicker and show you some videos. So Rakia is a non-for-profit organization dedicated to advance the space ecosystem, inviting everyone to join. Through academia, industry, research, and the arts, and by promoting private, public, local, and international collaborations. To explore the universe, a certain level of courage and curiosity is required. A single glance reveals both present and past. Like the light emitted millions of years ago from distant stars, light that travels through space and time, reaching the eyes, our eyes, en route to infinity. In the Indian tradition, the crown chakra, also considered the highest one, is our connection to the universe. It is directly aligned to seek enlightenment and relationship with the cosmos. Rakia launched its exploration 5 years ago, joining a unique international crew that you will see here on the video, hopefully. Here they come. The first private astronaut mission to the International Space Station, knowing that the involvement of humans will increase public attention, just as India noticed recently. This was so well expressed by Sophocles 2,400 years ago, where he said, "Numberless are the world's wonders, but none more wonderful than man." And teamwork, obviously. Just to demonstrate how an innovative attempt to make high-quality lenses in space from a liquid polymer was followed by creating lenses in space at an unlimited size from liquids. But that inspired creating water lenses, or a telescope made out of water. A lesson about phase tension of liquids, pushing a ping pong ball into a bubble of water. And a water sculpture that can only exist in microgravity. Another example is the research of phenomena in the atmosphere, observing and collecting data from the ISS, from above the atmosphere, about events like aurora and TLEs that appear above thunderstorms. These are various types of electrical discharge in the upper atmosphere. All the activities of Rakia are measured by their contribution to the United Nations SDGs, the Sustainable Development Goals. And these are the results of the mission. And now, here in India, we are honored to cooperate with CMS, City Montessori Schools in Lucknow, in UP, in organizing the educational content of the voyage of astronaut Chooks from Lucknow to space. It is named Vyomutsav, Sanskrit for a celebration of space. So we all wish him and the whole AX4 crew a great journey. Thank you.
Thank you, Etienne, giving us insight of Rakia, the exploration for all. That's your slogan. Over to Victor. Can you give us current and the future plan of ISRO in space exploration? You can give some insight of that.
As Dr. B.N. Suresh has highlighted in his lecture, the Indian space program has been always rooted for the benefit of common man, as envisioned by our founding father, Dr. Vikram Sarabhai. And that is relevant even now. The space data is touching every day, every man's life, whether it is communication, whether it is navigation, remote sensing, and whatnot. And the space program, if we see, we have currently 50 plus satellites in orbit. And our aim is to almost triple it, 150 plus satellites in the next 5 years or so. And of course, with the support of the private sector, the growing private sector in India. Now, coming to specifically to the space exploration, as everybody know, we had the Chandrayaan-1 mission, which led to the discovery of water on the moon. The Chandrayaan-2 mission, which was one of the best camera, the optical camera, to map the lunar surface. And of course, the Chandrayaan-3, which led to the first time landing near the South Pole region. And we had multiple missions, including the Aditya L1, the Solar Space Observatory, the SpaceX mission recently done for space docking. And also, we are now clearly charted out a very clear roadmap for our future missions. The series of we have done it in 3 parallel tracks. The Chandrayaan series of missions, starting from the lunar sample return mission by around 27-28 time frame. And then we have the Gaganyaan mission, which is now the topmost priority, where we are planning the first uncrewed mission this year itself, and then followed by multiple uncrewed missions, and culminating in the crewed mission in the beginning of 2027. That is the kind of time frame we have put. Then we are going to have a series of further repeat Gaganyaan missions and the development of the Bharati Antariksh Station, where we plan to put the first module by 2028 and complete the building by 2035. And that, of course, will be with the support with the international collaboration, where it is experiments or technology and whatever it is. And then, as envisioned by the Honorable Prime Minister of India, we have already charted out the roadmap for ultimately an Indian landing on moon by 2040 using our own rocket and our own the satellite, the spacecraft modules. So for that, we are in the process of developing new launch vehicle which will be cost effective, which will be reusable, and which will have the ultimate capacity and the capability to have that much of payload to carry the human to the moon. So that is our roadmap. And also we have radar, the mission to other planets, including the landing on Mars, the Venus orbiter, and also plans to have a mission to ExoWorld and many more. Thank you.
Thank you, Victor, giving insight of current and upcoming programs of space exploration. Over to Lisa. I'll request you to give us the sense how you are doing international collaboration and giving us insight of what activities are being done in your Space Industry Association of India, Australia. Yeah.
Thanks, Rajiv. Namaskar, good morning, distinguished guests. I just want to make a few quick slide changes so I'm up here as well. So we are witnessing a democratization of space exploration like never before, as many countries enter the arena for the first time, and as we move towards the privatization of space, with governments no longer the only ones at the helm. We're witnessing new space agencies launching, we're witnessing countries gaining their first astronauts and countries launching their first satellites. It's truly an exciting time for the global space ecosystem. I would like to congratulate CASA, the Korean Aerospace Administration, for establishing their National Space Agency in May last year, and the African Space Agency, which was officially inaugurated just last month. And I know that there are still other space agencies yet to launch, which is very exciting. Coming to astronauts, in 2024, Catherine Bennell-Pegg became the first Australian citizen to train as an astronaut under the Australian flag at European Space Agency's Astronaut Centre. And in April this year, Jannicke Mikkelsen became Norway's first astronaut participating in the Fram 2 mission with SpaceX. Oh, wrong way. Turning briefly to satellites, at the UNUSA STSC 2025 meeting in February, the ambassador of the Republic of Guatemala spoke about how Guatemala launched its first satellite, Quetzal-1, in April 2020, and he emphasized that whilst they remarkably made 70% of it at home from scratch, cooperation makes it viable. And in March this year, Botswana launched its first satellite in partnership with Dragonfly Aerospace on SpaceX, with many other countries having launched their first satellites in between, and acknowledging Rwanda's was in 2019. So the key to success in all of these examples is international collaboration, as Rajiv said earlier. And we all have our unique advantages and strengths that we should leverage as much as possible. Turning now to Australia, we've had significant global collaboration through government agencies, private sector partnerships, and academia. And if we take India as an example, ISRO, an Australian space agency, signed an MOU in 2021, and in November 2024, Australia formalised its support of India's Gaganyaan missions, which will allow our agencies to work together on crew and crew recovery. We have some fantastic examples of Australia-India industry collaboration through the International Space Investment ISI Projects Program, and we should further encourage our respective governments to provide more opportunities such as these for our industries to collaborate. As an industry association, we are committed to breaking down barriers for our organisations to do business internationally. We have been working really closely with our MOU partner, SIA India, to do exactly this, and there will be some news that we're announcing soon with some fantastic reports that we have, which will break down the trade barriers. And we have many other programs as well, such as the MATES scheme, which is really exciting for academia to exchange students between India and Australia. We look forward to continuing to grow our partnership with India, which is one example of how Australia can collaborate with other countries. As Space Industry Association of Australia, we welcome global and inclusive space exploration and look forward to collaborating with incredible organisations throughout the global space ecosystem. We also warmly welcome you to IAC Sydney 2025 in September, where we can further all of these connections. Dhanyavad. Thank you.
Thank you, Lisa. So I think now we will have some interesting insight of what you are doing. So we'll have few questions. First question is to hand it from Rwanda Space Agency. See, you gave an insight of how your private companies and your Rwanda Space Agency is working towards up and downstream and applications for various utilization of their application for the space activities. Now, what is your view on the spacefaring nations, how they can collaborate, and what do you expect from them for those upcoming space countries like Africa?
Thank you. As I mentioned, space is relatively new on our continent, the African continent. And if I can talk specifically for Rwanda, when you look at space exploration, it's something that we are exploring at the moment. And we understand, as our country, Rwanda, we are a landlocked country, but not space-locked. So what does that mean? This means that we are looking for international collaboration. We are looking for partners that can partner with us with a shared mission and vision. And us putting in place the space policy and the 10-year strategy is really to facilitate the private sector, because there's nothing that you're going to achieve in space if you don't allow private sector to invest in your country. So we are putting on policies and strategies that will help them have their companies in Rwanda. And if I can talk about Africa as a continent, we are still a continent that really focuses in agriculture, and when you look at the downstream part where we are talking about Earth observation applications, these are the applications that can be used to advance the space technology and then also inform the decisions when it comes to informing decisions on our continent. So really, what we are trying to do and what we are trying to achieve is look for international partners that can invest in our continent, but with a shared mission. And we are doing that with putting all the policies in place that will facilitate the partnerships. Yeah.
Okay. Thank you. So the next question is to Eric. You are already having you worked in ISS, ESA has, and also have international lot of collaboration. How do you think the new ways or innovative technologies or the new ways of space exploration, which can give you some insight on that, and what are the security or safety concerns which you think will be there from your side?
Thank you for your question. When you think about new ways to do exploration, I would take two examples. We have in Europe, forward the cargo towards the space station using the automatic transfer vehicle, the ATV, some years ago. But now we are launching a new project that is a LEO return cargo vehicle. The idea is to go to the space station, but also to bring back the cargo on Earth. So that is, of course, a very important development that will be on the table of the European ministers in November. But not only is this for us a totally new development that will, I think, be very useful for Europe in the future, but what is important is the way we do it. As a space agency, we have always developed our program by putting on the table the requirement, telling industry how to do things, and pushing industry to make development programs. Here we are doing it completely differently. We are not telling them how to do it. We are telling them we would like you to offer us a service. And we would like by 2030 to have a service to the space station. And we have organized a competition on that basis. And we have selected two teams, one with Thales Alenia Space, the other one with the exploration company. And the aim is to maintain this competition and to have two companies that will provide this service to Europe in the future. This is really a new way to look at space development from an agency point of view. I would take another example, completely different, which is the Lightship initiative in Europe. What is the idea? The idea is to make, for the scientists, the exploration of Mars, the science on Mars, more cheap and more sustainable. They also launched a competition in Europe, and we are conducting 4 studies in parallel, financed by the mandatory budget of the agency. The aim is to provide the tool to bring the payloads to Mars using electric propulsion, and also as part of this bus that will bring the payload to Mars, to provide telecommunication facilities that are, of course, indispensable. So you see, those are two new ways to develop exploration for the future. In one side, giving more responsibility to industry, looking for a service. On the other side, to offer to the scientists a way to do it in a more sustainable and also cheap way.
So, but on the safety regulations, what is your
if you think about safety, let's take that. Of course, this is a multi-domain element, but let's take the three angles of safety. The first one is about space debris. You have more and more space debris. This is, in particular, for human spaceflight, quite a threat. And there you can do 3 things. You can ensure that the space stations are resisting to micro debris, but also you need to have capacities to move in order to avoid the debris. But more important, I think, this is a global effort that is to be made, is to reduce the number of debris. And ESA has launched the Zero Debris Charter, because we would like to be a model agency, and we are asking and we are offering to all the space actors to join this Zero Debris Charter. Today we have more than 100 signatories, states, industries, organizations that are supporting these efforts. So this is one domain, but of course, when you think about health, this is also a major domain. How to exchange physical data, psychological data among us to know more, and to how the humans are resisting to a long stay in space. A third domain is life support. life support is essential. Water, food, waste management, oxygen. This is, of course, a point that is extremely important. When you think in terms of collaboration, the important point there is interoperability of those systems. And this, I think, I'll just take you those 3 examples.
Yeah, definitely interoperability is the most important thing. Thank you. So over to Bob. Now, see, you are having this European Space Research Innovation Center, and you are facilitating the private companies there. And this, what is your challenge which you have, because they are without funding, without sovereign funding. These private industries have to do innovation, and they have to venture into. So, what's your challenge? What is your experience on that? And how you are supporting them in making space accessible for the future generation through the industry?
Yes, so maybe a very interesting example to illustrate a bit how we support industry and commercial activities in space is the example of iSpace Europe in Luxembourg. So on the innovation side, we support them to develop lunar surface mobility to complement their lunar transportation services and help them actually operate different activities on the lunar surface. And for that, we have different R&D contracts. Also through ESA, we help iSpace develop the technology itself. And then on the other side, also on the enabling side, as a country, we also want to provide the right framework, legal framework, regulatory framework for them to be able to operate. And that's where I think it's very interesting to the example of the Space Resource Law, that we now issued the first authorization, or gave the first authorization to iSpace for their current mission. So on the mission, several years ago, NASA awarded, I think it was 5 contracts to procure, regulate on the lunar surface from a company. And so iSpace Europe, they won one of these contracts, and is going to fulfill with the current mission that contract. And while it's not a sample return mission, it's a transfer of ownership on the lunar surface, and it's more about going through the end-to-end legal and regulatory process to do this and demonstrate that you are able to do these type of commercial activities on the lunar surface. It's very significant first step. So currently, the rover iSpace developed in Luxembourg is flying on their lander developed in Japan. It's currently on its way to the lunar surface. It's expected to land on the 5th or 6th of June, depending on which part of the world you are. And then they will, with the rover, they will operate that activity under the Luxembourgish law. And I think it's a really nice first example how the right legal framework supports industry to get also investors. So iSpace is, to a large extent, also has private investors to do this type of activities.
Okay, thank you. So how many companies are right now working with your innovation center?
In Luxembourg. So in Luxembourg, in the meantime, we have more than 100 different entities active in space.
Okay.
And it grew from, I would say, 10 years ago, there were around 20. So from 20 to more than 100.
Yeah, there's a traction there. Thank you. Thank you. So I have a question to Etienne, the first commercial crew to current ISS, which is through Rakia. I have one question to you, two questions rather. One is you have to share your experience. What was your experience as an astronaut, and any message to your friend Shukla? And second is how you are transforming the scientific research and experimentations to the various STEM and various. You showed that how you are doing the manufacturing there and giving by doing experiments. But where is the economic opportunity? How do you, because you are a businessman and you are also putting your own money there. So how you are talking about taking care of economics? Over to you.
So first, I wish Shulks a successful mission, and he has a great responsibility carrying the largest nation on Earth and leading the way into space and participating in human space flight and doing all what he's planned. He has a very busy work plan, which will require him to be focused during the whole mission, and I'm sure he will, because he's training well and is going to be a great astronaut. He is an astronaut. He will be a great astronaut in space. And the second question was about the commercial potential. So first of all, we have AI, right? AI, Rajib, is going to take over.
Yes.
Right? We're going to be employed by AI? Well, I don't think so, but because first of all, the AI has a huge capacity of analyzing data. So that will help us on our missions, on planning missions, on analyzing information real time during missions in order to take the right decisions faster. For example, Israel is planning now a satellite, Ultrasat, by the Weizmann Institute. It's an ultraviolet observation of the universe. It's planned to be launched in about 2 years, and it will be a geostationary satellite looking into space. And all the information it's going to collect will be downloaded to scientists all around the world so that everyone can use that material, analyze it, reach new conclusions, understand science better. So AI will be a great assistant. The concept of commercial flight, which you asked, it hasn't yet been proven that a space station can survive on a commercial basis. It's yet to be proved. All the companies are struggling with that issue. The agencies need the platforms in space. The International Space Station is already over its expected life. It was planned for 20 years. It's reaching very soon 30 years in space, and it's only man-made, so it cannot survive forever. So the companies are dependent. The companies that are building space stations are today dependent on the governments using the platform. They have to build the platforms with the proper facilities, with the proper laboratories, so that commercial companies are interested to perform science there. Like the Chancellor described, there's so many areas of science. So the stations must provide and facilitate the possibility of those researchers to work there. And they will pay for it. They will pay, it will be expensive, but the more launchers there are from Europe, hopefully they will have a human spaceflight launcher, and China has, and Russia obviously, and the US, and there will be more coming, so the costs will come down, and it will be easier to access these low Earth orbit stations and do more and more research at a more reasonable price.
Thank you. Thank you. Over to Victor. I think our Honorable Prime Minister gave the vision on the very first day on the space, and our Chairman ISRO gave the blueprint of various technologies which will be developed over 2047. What is your view on what are the new innovations which are required for meeting that ambition of having antaricts and also going to Venus and going multi-planetary missions?
Okay. I think when we talk about innovation, one of the best specific examples which I can quote is recent. What we have seen is POEM experiment, the PSLV orbital experiment module. It is the best example of innovation, how cost effective we can be, because the upper stage of the vehicle is anyway, it is discarded in space. And what we have done is how effectively we can utilize that upper stage And in that mission, what we did is almost 30 plus experiments, including around 20 plus experiments, including 10 from the private space sector, ranging from growing crops, growing plants in space, robotics, propulsion, and many things were demonstrated. So it becomes very cost effective because we don't have to build or invest in a full satellite for that. We are using the upper stages already there and how we can do experiments on that. So that is one of the experiments. And coming to your specific question on the space exploration roadmap for 2040, what I can say is across ISRO centers, we are right now running almost 2,000 plus technology development programs across ISRO centers, whether it is launch vehicle building, whether it is satellite building, whether it is application, payload development. And coming to specifically to launch vehicles, our focus is on cost-effective, again, reusable launch vehicle. Because independent access to space is always very important. It gives strategic advantage to the nation. And everything propulsion is another important area where we are focusing. And coming to spacecraft domain, if we see there are multiple technologies which we are developing. We have recently demonstrated the SpaceX experiment, which was docking in circular orbit. And our next step will be to go for the next level of docking, where the docking will be in the elliptical orbit, which ultimately we have to prove that because we are going for lunar sample return mission or many other crewed mission to moon, etc. And there are multiple technologies which are getting developed. If you see in the communication area, we have software-defined payloads, the quantum technologies which gives key QKD features. Then again in satellite area, onboard refueling, space robotics, AI, and in downstream data also, the AI-based data processing, multiple. So these are the key areas which we are now focusing.
Yeah.
Thank you.
Yeah, maybe a follow-on question on that. How ISRO is able to give a cost-benefit analysis? How the cost of if the Mars mission was also, if you see, and now the new compared to other technologies which are developed by other space agencies, ISRO's benefit is there. What is your view on that?
Now, one thing what is most important is if you see the cost of the systems which we are developing, if you see typically a launch vehicle, I think almost 80 to 90% of the items which are being built in the launch vehicle is coming from our own. Yeah. So the dependency on the import and dependency on the independent ability to make it ourselves and how the Indian industries can cater to the requirement. So that is one of the key elements in how we are able to contain cost and how we are to effectively control the cost over the years. That's, I think, one of the most important thing. Thank you.
Thank you. Thank you, Victor. And I have a question to Lisa. You are into the lot of collaboration and international cooperation with various countries. Do you face any challenge in terms of key policy initiatives taken by various governments? And how do you see the way forward for international collaboration for sustainable space exploration in the future?
Yeah, thank you, Rajiv. A very timely question in terms of policy and what we would love to be able to see. We actually, at the same time, as many people know, the COPUS, the legal subcommittee, is actually taking place within Vienna. And one of our esteemed professors in Australia, Professor Stephen Freeland, is actually proposing the first draft of the resources policy for space as well. So how do we actually ensure equitable access to space resources in lunar environments and so on, which I think is really timely. It's really exciting as we start to focus on lunar missions and so on. So plenty of opportunities there to actually determine the best way to collaborate. And there are further, obviously, policies around long-term sustainability in space, which Australia subscribes to. I think having the policies and the guidelines are useful, but then equally, how do we take it one step further? So we work really closely with Australian Space Agency to determine, well, what is right for sustainability? You know, can we take these long-term sustainability guidelines of the UN and take it one step further? What is the policy that we can have as Australia? Does industry actually subscribe to it, and how? Because sometimes sustainability can come at a cost, and we do need to realise that. But if we don't do something now, then it will be too late. So we just need to make sure that everyone is on the same page, everyone subscribes to it, and there's a practical way to actually make use of these guidelines. So they're just a couple of examples, but I think it's definitely moving in the right direction in terms of policy.
Okay, thank you. So maybe we have a couple of minutes, so maybe I have a question to Etienne. you have been in space. What was your main, how much percentage of time you were able to give on the operation or on the research? How you made that balance of this? And conventionally, astronaut has to do how much percentage of time in balancing these two activities?
It's fortunate that private astronauts had the opportunity to build their own program. So our program was built, 80% of the time was research, art, creation, education, outreach. And only 20% was left over for the other stuff. National astronauts' balance is very different. Most of their time, they are responsible for maintaining the platform. And there's a lot of work to do, especially as the station gets older. So the split of time was exciting. We were involved in the general schedule of the 11 astronauts on board. All the 11 astronauts are coordinated and share their time. Everyone knows where the others are, and they know what the others are doing. So if someone has a few minutes free, he can go and help others. Time in the cupola to watch Earth is exciting. It's breathtaking. I was lucky that one of the experiments which I presented to you was following thunderstorms at the dark 45 minutes over different places on Earth. And luckily I was there, so I had a lot of time to watch Earth from space, and I can talk about it for hours.
Thank you. Thank you. Thank you. Giving a lot of insight of how the outer space and exploration for all can be done through technology, innovation, and commercial activity. Thank you, each one of you. Thank you very much. Yeah.
Thanks a lot to all the speakers and the moderator for this really interesting session. And I would like to ask you also to come in front to do a group picture. I would also like to ask our distinguished highlight lecture speaker, Dr. Suresh, to come up for the picture. While this is done, I would like to thank you for your attention for this great plenary this morning. We are now breaking for a chai break, a very nice tradition here. And I would like to ask you to be back here again at 11 when we proceed with our GNF program, the first GNF session of today that will feature various astronauts, so a very interesting session. But also at the same time at 11, the technical sessions will start again. So please choose whatever is in your interest to join. Be back at 11. Thank you. Ja, ich brauche es unbedingt. GLEX drüben. Huh? No.
What can I do?
It would be so proud.
Ask all of the astronauts to get on stage, otherwise people will come on
We don't
stage
do
and
the-
will never manage to do.
We don't do a group picture.
Yes, but right after that, off. Because
Please.
otherwise people will come on stage to get pictures with astronauts and,
Yes,
and,
yes,
and
yes, please help
autograph,
us.
and we
Yes.
never go. So
Did
Martin and I-
Constance manage to put her back?
Yes.
Tell me when we can start.
यहाँ रखवा दे हाँ हाँ बस बस अभी
Welcome back, ladies and gentlemen. We are already a bit late, but the next GNF session will be a very special one because it will be a session that will feature our distinguished space flyers. And of course, this is the one-off opportunity for all of you also to address your most urgent questions to the astronauts using our Slido system. So please do use it, send up questions, upvote them, and I will be happy to direct as many as possible to our distinguished panel. Now, the title of this GNF is IAF International Astronaut Session, Life Between Worlds, the Astronaut's Experience. And it is my distinct pleasure now to call up on stage one by one our distinguished astronauts. First and foremost, Mr. Rakesh Sharma, if you could come up. He's India's first astronaut. Rakesh flew aboard the Soviet Soyuz T-11 mission in 1984, a former India Air Force pilot. With his mission, he marked a milestone in India's conquest of space. Rakesh, welcome. Next, I'm pleased to call up Alpa Gezeravci. Alpa is Turkey's first astronaut, and he flew on the International Space Station last year in 2024 as part of the Axiom 3 mission, marking a milestone in Turkish space exploration. Welcome, Alpa. Next, Haza Al-Mansouri, the first Emirati astronaut. Haza spent 8 days on board the ISS in 2019, becoming a national hero and a symbol of the UAE's growing ambition of space exploration. Welcome, Haza. Next, Sirisha Bandla. An aerospace engineer and commercial astronaut, Sirisha became the second woman of Indian origin in space when she flew on Virgin Galactic's Unity 22 mission in 2021. Welcome, Sirisha. Next, Michael Lopez Alegria, a veteran NASA astronaut and record-holding spacewalker. Michael now leads commercial space missions with Axiom Space and commanded the first ever all-private crew to the ISS in 2022. Next, Aitan Stibe. As Israel's second astronaut, Aitan flew on Axiom 1 mission in 2022, which was commanded by Michael, promoting science and education through the Rakia mission during his 17-day stay on the ISS. Welcome, Aitan. And last but not no, we have two more. Angad Pratap, an accomplished test pilot with the Indian Air Force. He is one of the astronaut designates for the Gaganyaan mission, and he represents a new generation of Indian space pioneers preparing for the country's first crewed space mission. Angad, welcome. And now, last but not least, Gopichan Totakura, an entrepreneur and pilot. Gopichan became the second Indian-born space traveler. He was flying on Blue Origin's New Shepard program on a suborbital mission. An applause for all our distinguished panelists here. Thank you. Such a pleasure to sit up here with you. Let me start, of course, with our veteran and hero here in India, Rakesh. You have flown into space more than 40 years ago, and still today, and I see you walking around here in this convention center, people are getting fanatic when they see you. They all want to have a selfie with you. It's really exciting to see this. I would ask you a question. As first Indian to fly in space in 1984, how did you personally carry the weight of these national expectations to you? And how do you see your legacy shaping then the development of India's space exploration program?
Well, I must confess that I was not very well prepared for what to expect after the space flight. Of course, I was prepared what to do during the space flight, but the kind of impact the space flight itself had on our countrymen was an eye-opener. Just to put it in context, television didn't have a very wide footprint, but a year before I flew, we had the television spread quite a bit. So this was streamed live in every living room, and I'm sure that even our countrymen did not expect to see science fiction come alive, because till then it was something out of this world, and they were seeing their own countrymen as part of that. So I was quite unprepared after when I returned, the kind of impact it had made in the collective imagination of our people. Now, as far as the legacy is concerned, that's too big a term. I would really not like to identify myself with that. It's just that there's been a 40-year gap, and at the end of 40 years, I think our countrymen are quite excited and prepared to see Angad and his colleagues, which is the next lot of Indian astronauts, and this is part of the success which ISRO has achieved over these years, because now is the time ISRO felt that we need to go to the next level after having realized the earlier aims of utilizing space technology for the benefit of our countrymen. So they are excited now, and yes, they haven't forgotten me, because there has been nobody else in between. So I think we are in for some exciting times, not only in our country, but even otherwise, because we are getting ready to do stuff which we've never done before, which is to colonize the moon first and then Mars.
Well, thank you very much. I would like, yeah, please go ahead. I would like to ask also two of the first-time flyers, Haza and Alpa. I mean, how did you manage to carry the load of all these national expectations, being the first national astronaut? Who wants to go first?
It's a pleasure to be here, and it's really amazing. Human space flight is really something out of this world in terms of the impact that it has in humans and also in generations to follow. We saw that impact in different countries, and in UAE it was something that we felt like in my return to my homeland, and after the flight, the kids were there like happy and saying that we want to be an astronaut, you know. So it felt for us like Apollo era in UAE at that time. And it's a big responsibility because the things that we trained on, the things that we done on board the station, the experiments, we have to share all of these knowledge and all of these experiments with everyone on ground here, not only in UAE, but in the whole countries and around the world, because it is important to share this knowledge, to spread the word of exploration and the importance of that and the impact on the generations to come. Today we met kids at the hotel, at the lobby, and they were like, they are from India, and they recognized me, and it was really something that to me is amazing, because they felt that when they saw the blue jacket or blue suit, they felt that this person does not belong to one country. He belonged to everyone. So that's amazing to feel that and to have that impact in everyone. So that's really something great.
That's great. That's great. Alpa.
Christian, thank you so much for the question. It's a really important question, actually. And dear guests, welcome. It's a great pleasure for us to have the chance to be able to meet with you all today. When it comes to Turkey, we have a different story than our equivalent countries over here. It's because even though we were engaged as a country who have been working in the space arena, but just the satellites, it was our very first manned space mission on our centennial. And unfortunately, that coincidental time that we decided to make it on our centennial came up with another unfortunate coincidence, which is an earthquake. On the 6th of February, 2023, the Republic of Turkey has experienced the biggest earthquake disaster in its history. And the decision was already made. And when you experience this kind of a disaster, you are going back to the Maslow's triangle. Nobody cares what your ideals, what your really dreams about, to inspire your next generations and everything. Your question and decision is being questioned. So our governments were really challenged with its decision that was going to really inspire our next generations, while the people were staying there without a home, without a food, even though the government really provided all this required humanitarian help that they need from the day one. So at the end, after a really difficult amount of time of questioning this decision, they standed really strong behind their decision, telling that if we focus only today's difficulties, then we would be stealing from the dreams and the nature of our next generations. So they really stood strong with that, and we would really appreciate Axiom Space's support as well in that manner, in that decision, to how to handle that. So after returning back from the mission, my initial responsibility was to keep touring and traveling all around the country and letting the people why this decision and why this mission was really needed for our next generations, why we needed to do that. And up until so far, within the last 15 months, I have been to more than 160 cities and executed more than 350 events so far. And we keep saying, until we make this unusual field of practice up in the space, make it usual in every mind of our children, we will continue to travel and meet with them and let them know why we need to make it there to the space in order to maintain, in order to keep this sustainability term really strong here on Earth, because everything that is being made up there is reflecting strongly back to the Earth.
Well, thank you so much, Alpa. I think this is really the most important thing, the role astronauts and astronauts flight play in providing really hope to people and inspiration to people who are suffering. So thank you very much for this. Sirisha, yesterday we heard already your very inspiring story, how you wanted to become an astronaut and finally became an astronaut. What would be your advice to young people that would also like to follow your footsteps and also become an astronaut?
Of course, thank you for the question. First of all, I was also one of the people fangirling over Rakesh when I met him a couple of days ago and had Mike actually take a picture of me and Mr. Sharma. And Mike also was 2011 is when I think we started working together, and LA was one of the first astronauts I worked with and a mentor. So I do find it incredibly honor. It's such an honor to sit amongst this panel. I would say in terms of advice, everybody's journey is their own. I think many of us have said this on the panel. Find your passion. Because you're going to be working very hard, but if you're not excited about it, you're going to be miserable. Make sure what you're doing is something you are very passionate about and that really excites you and makes you want to wake up every morning and go, give it your all. And I always say, it's okay to be the first, but make sure you're not the last. So you can make the first footstep, but make sure you keep the door open for many others to follow in your footsteps. And especially for women, we just passed 100 women in space last year, which is incredible to think about. Out of the 700 of people, over 700 people that have gone to space, we just passed 100 women last year. And when I flew, I think it's still in the 60s, and I was not prepared for the number of messages from young women that didn't necessarily say, oh my gosh, I want to be an astronaut now too. It was, wow, I want to be an engineer, I want to be a physicist, I want to pursue some of these STEM fields I didn't think that women belonged in. And I think that's the key for people, adults in the audience as well. Sometimes it's easy to inspire, but the hard work comes after that in creating an environment where people feel like they belong so that they can continue to pursue their careers in a way that really matters.
Well, thank you very much. We are so blessed to have you as the only female astronaut on this panel here, but I think the message is very, very clear that increasing the diversity also amongst the astronauts in future is a very important thing, and you are a perfect role model for young people, of course, and as you say, not everybody who initially wants to become an astronaut will become an astronaut, but if they choose then also topics like STEM topics, and there's so many ways to support astronaut flights as operators, as engineers, as scientists, as physicians. Thank you very much. Michael, I mean, you had such an outstanding career at NASA, and now you are leading private space flight, commercial space flight with Axiom, and you are such a strong supporter of the IAF. You are at every of our event, and every time you come, you are telling new exciting stories to our delegates and the audience. It's really great. You have led and trained several first-time flyers, actually, from Israel, India, Turkey, Saudi Arabia as well. What is the advice you are giving first-time flyers when they are preparing for the mission?
Well, first, let me echo Sirisha's words and say what a lovely pleasure it is to be on this panel. I've been on more than one panel with a lot of astronauts, but this may be the most interesting, diverse group, and it's a pleasure to be on stage with all of you. So we have a lot of training that we go through before these flights, as you can imagine, whether it's the Space Shuttle or the Soyuz or the International Space Station or the Dragon, and pretty much it's a very solid system that takes care of all the advice. Now, I can offer some tidbits about how to prepare to what your body is going to feel like when you first get into microgravity, how to float around carefully, how to use the bathroom, things like that. But the advice that I think is the most important is to enjoy yourself. When we get on board the ISS, it is work, work, work. It's really hard to take a moment to inhale and just absorb what's happening. Go spend some time in the cupola to look at the Earth as we go by. Every 90 minutes, make one revolution. It's a very important piece that it's very easy to skip if you're not really conscious about that. I wish I had had that advice from my crewmates the first time that I flew. They told me how my body would adjust to microgravity. They told me all the things about the training that I'd already learned from all the instructors, but it's really important. We are very privileged up here to have had the experience that we had, and it's something that you really need to work at to sort of internalize, because otherwise you can get very caught up in what you're doing to do the science for your country or even doing outreach to the people of your nation. Don't forget to enjoy it.
Yeah, thanks. I've never seen an astronaut on a station or in space that was looking sad. It's always kind of smiling and excitement. Hey, Dan.
Can I
yes,
add
please.
just, many ask about fear, right? Astronauts going to space, what are you afraid of? And so first of all, I want to say that go with Mike. I mean, he is so confident, right, Alper? He gives you all this confidence. You're sitting up there 3 hours before launch, and you hear the rocket being refueled, the valves opening, all kinds of strange noises. You hear nothing from the ground emission control center. And then and he's quiet and peaceful. That means that we can also be quiet and peaceful. And that's so important during a mission. I think the biggest fear we had during the mission, you want to say something about that?
I was going to add that you were so peaceful that you took a nap.
Yeah. So the biggest fear during the waiting moments before launch is that it is canceled, because you work, there's such a build-up, there's such a preparation that you really want it to go on, and you've seen so many launches before you scrubbed at the last moment or the last hour. So we're really expecting this to happen. And then the countdown comes. And there's a guy in the mission control counting down in a very peaceful way, 10, 9, and we're shouting the numbers in the Dragon and all excited, and he's very calm. And then really the experience of the launch is much more smooth than expected. The movies always show it very shaking, but it's not. It starts very slow, the G builds up, it's a very pleasant liftoff. 3 minutes later, Falcon 9 separates and returns to Earth, and MLA tells us, welcome to space, now you're astronauts, we can go back. But the whole mission is in front of us, and it was exciting.
Well, thanks a lot for this insight, and once again, congratulations to the first ever private space mission, actually. I mean, this was a totally new model for space access. How do you see the significance of this?
For us, for me as an Israeli, a bit like Alper and Haza, I was starting from a lower point, because our first astronaut did not survive. He launched on the Columbia 2003 and did not survive. And so the sentiment in Israel was negative for human spaceflight. So the government was completely not promoting new astronauts, and the private initiative came as a surprise, as a happy moment where the government could join and not lead. And that was a very successful plan. They joined, the government offered many experiments and scientific activities and joined in the mission. So the commercial leadership of a mission is exciting because you have the choice. You build your own mission. You decide what you want to do. And I'll give one example of something that no government astronaut has the privilege to do. I did an artwork which is sit there on the station during work hours and don't do anything, and take a video of yourself. I don't know who knows Marina Abramovich. She did that in museums in the US, but I tied myself on the ceiling, and during the work hours, everything was going on in the station, and I was just not falling asleep. Why do you tell that? I didn't fall asleep, I didn't meditate, but I was conscious of what was going on and watching it, and that was one of the top experiences in space, is actually to spend this very valuable astronaut time doing nothing.
That's great. That's great. Great privilege. Thanks for sharing that. I would like to ask Angad, I mean, you are part of this next generation of Indian space flyers, astronauts. How does it feel to train for a mission that will actually mark a new era for India? And what was the main surprising aspects or most important aspects so far on your journey?
Thank you for having me here, and I would like to first of all thank my parent organization, the Indian Space Research Organization, for coordinating this along with IAF, and to be here amongst this illustrious panel is a great moment. Yeah. So talking about our space program right now, we had 2 interactions, one with children and one at the Indian Institute of Technology, and talked about it briefly. I feel to be a part of a space program which a country is single-handedly spearheading, even when it is not fixing or it's not matching with what the rest of the world is doing, wherein there's a lot of collaboration which is happening in human spaceflight before people can venture, is a big thing in itself. That talks deeply about the kind of commitment the country is making. And as all of us are aware that India is not about being the first, I have done this and all those things, but it's all about, you know, whatever we learn, whatever we achieve in this journey of ours, we want to share it with the world. In this space program, it's a very, very unique space program. Of course, things like space, especially human space flight, they take their own time. But I'm really amazed at the approach which my space agency is taking, wherein there are a lot of activities which are planned related to human spaceflight, as all of us are aware. In the case of ISRO, they have kind of telescoped a lot of activities, wherein we can see that we have a human spacecraft program going on. Docking has been proven in parallel. The capability to go to the moon and come back to the moon is in progress in parallel, these are the same technologies which will eventually take the human being all the way to the moon. We also have the Bharatiya Antariksha Station program being built in parallel, and to top it up, the next generation launch vehicle which will be able to carry heavier and bigger parts to space, which is essentially and largely a requirement of the human space program, is also underway. So if you see, this is a 4-pronged approach, 4 parallel activities happening, and it's the same set of people who are continuously switching and doing the same thing. We are not very, very luxurious in the way that we can devote different sets of manpower. So to be a part of this program, in which I will have probably the first human space flight happening, and the Indian space station already there in orbit or about to be in orbit, it's of course a great feeling. The journey so far has been very, very exciting. being an astronaut is a different thing altogether. I'm completely aware there are all the other panelists have already been to space, and I'm just taking the baby steps. I especially take inspiration from people like Sirisha, who against all odds have not junked their space dreams, and they've still managed to reach. As far as space experience is concerned, I believe, barring me, the rest of the panelists, they may be differing in the kind of space experience they have, but in terms of the quality that is required from a space aviator, all of them are same, and I salute them for that, and I have deep respect. Yeah, thanks.
Thank you very much for sharing these insights in your journey. Kobi-chan, I think it is the first time that you are attending an IAF event, and we are so happy to have you here, of course. You were the first space tourist through Blue Origin, and of course, this was exciting for everybody to see. Attending an event like this one, how important do you see this for you to promote space activities to the public, to the general public, to the youth, to the next generation?
So absolutely, thank you for the question. I think we've been talking about this over the course of the 3-day conference, but what's important is that it's definitely the first IAF event, but in India, as the country that we have with a lot of people, a lot of schools and universities, I've had the privilege of going around and talking to many of the next generation. They might not all want to be scientists and astronauts, but they are passionate about what they're doing, and they're very, very passionate about the little things in life that we talked about yesterday. So I think that it's important to realize that it's not just going to space, and it's everything else that puts that person, female or male, to go to space, and you have a portion to contribute to that. And that's sometimes more important than the actual person going to space and coming back. The mission can be 12 minutes or it can be 100 days. But all in all, there have been somebody somewhere has contributed who is not more often than you would know recognized for what they have done for that person to be on that rocket on that day to actually go to space. And I think it's very important for the next generation to realize that we had a lot of people coming up to me and asking that I want to be an astronaut. But then we had some who were like, I don't want to be an astronaut. There's a girl here, I think her name is Ria, and she's making a satellite box, a little tiny satellite out of Ahmedabad, and she's in the exhibition down there. And she was just saying that my goal and my dream is to make this accessible to every country to be able to take to space. It's not about when can I go, it's about when can my vision of this material be accessible to everyone to go. And I think that's very important. I think they should realize that the little that they're doing here will impact at 100x or maybe more up there. And sometimes that's all it takes, right? But we, I think, somewhere forget that we have to appreciate all the A to Z that comes in for the launch or for the space exploration to be actually possible. So I think that the message would definitely be to follow your passion, would definitely be to don't stop at the little things. That little thing would be the big thing, which would save somebody's life up there. So.
Well, thanks a lot for being here and for sharing your experience and your advices with the delegates. And we've certainly looked forward very much to welcome you also to our IEC in Sydney later this year as part of the IAF Astronauts chapter. I've prepared several more questions, but I want to switch it to the numerous questions I'm getting in on Slido here now to answer your questions. First, question to Mike. What difference do you find between flying with NASA on the shuttle versus Axiom mission?
NASA on the shuttle, was that the question?
Yes, NASA on the shuttle versus Axiom mission.
Well, there's a lot to unpack with that question. I think, let me start with the similarities. They're both around the same duration, usually about 2 weeks or so. I would say the shuttle timelines are even more specifically programmed so that when we launch, we already know what we're going to be doing for the next 10 or 12 days, minute by minute. And so we end up practicing doing tasks for practice on Earth as part of our training, whereas learning skills, which is on a space station flight, you generally learn to do skills, not knowing exactly what the task will be. From my standpoint, as a crew member on a shuttle especially, you're quite concerned about your timeline. What is the range of your duties that you're going to be doing throughout the mission, again, minute by minute, day by day. Whereas on an Axiom mission, and it's changed a bit from when I flew with Aton on AX-1 to when I flew with Alper on AX-3. But we have realized that it's probably better for the Axiom commander to be more of a helper, an assistant, a counsel, as opposed to having our own program. So whereas Aton, when he had a question about something, often I was already busy doing my task and he would ask another ISS crew member. We try not to be too much of a burden on the existing expedition crew. And so we've changed the model so that when Alper had a question, I hope I was a little bit more available to you to help. It's quite, in some ways these missions look very similar. When I say these, I mean an Axiom private astronaut mission compared to a NASA or ESA, JAXA, CSA mission to the ISS. They look very similar from the outside. The activities are quite similar, which is mostly science investigation and reaching back to the countries of the crew members. But internally, they're a little bit different in the way that they are my crewmates, but they're also my customers, and my job is really to make them first of all, ensure their safety, but also have them fulfill their mission and to have a smile on their face.
Yeah, they sure had. There are several questions actually to Angad about the inspiration that brought you to try to become an astronaut. So what drove you to put in your head to become an astronaut?
Okay, one of the basic inspirations that I had to become an astronaut was, of course, what is present here and all the other people who've already gone to space. I have served in the Indian Air Force for almost 16 years before I got an opportunity to get into the space program. Even before I had got selected for the space program, when I was applying for the selection process, I had a small inkling. I didn't know a lot about space. I didn't know a lot about what the astronaut community is exactly. But as a commoner, I had an outside feeling that here is a place wherein I will have 2 or 3 things which I will be able to do. One of them was to become a very, very humble human being, to have a kind of a global perspective, to become a mascot of our entire planet Earth. That was one thing which was there at the back of my mind, that I will be able to represent the entire humanity if I manage to become one. And the second thing, now coming to the slightly less philosophical, was I would have a very, very bright opportunity to develop myself and my capabilities and my knowledge in multiple fields. I would be definitely developing myself academically. I will be developing myself in all the qualities that are required in extreme environments. I will learn a lot about teamwork, about collaborating with people across boundaries, religions, no discrimination of any kind. And in the end, I will feel more human. Yeah.
Thank you. I have a question here about the psychological effects during the flight and after the mission. Anybody who wants to jump in for this? What are the psychological challenges? Rakesh, maybe?
I would just say one of the important training issues of mental preparation is preparation for failure. Because you go up with a load of responsibility, expectations of scientists, of children, of artists, and your chances of succeeding and satisfying them all are very low. So one of the mental preparations is to prepare for failure.
Rakesh.
Yeah, so what I'd like to say is that everybody who's been up into space to date, and a few of them are sitting here, all of them have experienced the so-called overview effect. And the strange thing is that the overview effect has been similar in everybody's case. I can say that with confidence. And the way it goes is that obviously like Prince Sultan bin Salman bin Abdulaziz of Saudi Arabia first mentioned that the funny thing is on the first day you're looking at your own country and then you start noticing that there are no boundaries. So that helps you see the Earth as a single entity. And then you start seeing the degradation which is going on, and that wakes you up to the possibility of environmental degradation. In my own flight, I've had the occasion to see a part of the Burmese, now Myanmar forest going up in flames. And then from those heights, you could also make out that the plume of smoke which was rising and which was clearly visible due to the upper air winds was moving east across many other countries. So that tells us that pollution really is no respecter of boundaries. And therefore, it's in everybody's interest, we need to make sure that the environment which we are enjoying, which is life-giving for us, needs to be protected. And it's the same if you look at from the outside how thin the layer is. I've not seen that myself, but I've read about it. And those astronauts who were privileged enough to go to the moon and return from there have seen it. And they've reported that the Earth looks more gray and less blue than it did between the first and the last moon return missions. So these are the things which go through your mind, and absolutely everybody, therefore, starts worrying about the only home we will have thus far. And Carl Sagan, of course, says it beautifully and very powerfully, that this is where we got to make a stand. So as we move forward and we are getting ready to set up societies in the moon initially and later Mars, I think this is the learning which we got to take with us instead of creating another far-off hell. I think we should start by recreating heaven, which we already are a part of, and we are, I think, busily destroying it. So this is my hope, and this is what I feel. All of us feel. We've come back with the same kind of feeling.
Yeah, you hear this from all the space flyers coming back. Sirisha, you want to add something?
Yeah, it's one mental preparation I actually did not prepare for, was that this mindset that spaceflight is not your peak. It's a platform to go on and do other things. For me, having dreamt of going to space my entire life, I did, after going the highest I've ever been, I had a little bit of a crisis on what to do next. And it is a mindset change that, well, this is an incredible, incredible experience, incredible journey that you're about to embark on. It is the first of many things that you're going to do in your life. And it's not the highest you're going to, actually, it might be the highest you go, literally, but figuratively in your life, you can use the spaceflight experience to do even greater things. And it's a mindset I actually did not prepare for and learned the hard way afterward.
Yeah, thank you. Maybe Gopichan and Alpa and Haza, you can comment on this question. What was, which flight event caused the maximum level of discomfort? No discomfort at all during the space flight, I expect.
Definitely, in different stage of the flight, there is different feelings. In all our preparation for our flights, we got so much of simulation and preparation for the flight itself. So to make us more confident about the machine and the knowledge that we gained, so that anything gonna happen during the launch itself, we have fully 100% confident in the machine That's gonna, there is different system that's gonna rescue us. But probably I think coming back from space is a little bit scary because it's like a falling stone, you know? It's like, so it's more like, I would say, you are just falling from sky with the sort of control, but, and there's only parachute that can decelerate everything at the speed you are coming down there. So it was a little bit for me, I would not say scary, but interesting, especially I remember with the Soyuz experience, when especially coming from weightlessness to experiencing 1G or like acceleration during the re-entry. It's up to like 5 Gs, but because you are coming from weightlessness, you feel that more than 5 Gs. You feel like it is like heavier, and you think, I'm prepared for this. Why it is feeling heavier? Because you are coming from weightlessness. And then when the parachute opens, it just rock you, you know, just because it's opening, and then just the whole capsule is just going for right and left. I remember the commander said, Alex Avchinin, he said like it's in Russian, he said like Gorky Park. It's like a roller coaster. So it feels like a roller coaster, but it was something that we expect. And then you saw the flames outside from the capsule. But inside we are safe and in a good position, and the impact itself, it was a little bit it was a little bit expected, but heavier. Couple of astronauts like relative to that, they said it's more like you are sitting in the front of the traffic sign. There's like a big truck coming and gonna hit you, but you are expecting that hit. So it felt like that. So it was nice, but it feels also good because you are coming back to Earth. So that was a great feeling. So probably that was more dynamic, I would say, part of the flight for me. Yeah.
Thank you. Kopichan, I have another question here as well. I would like to add this to this. What was your most unforgettable moment, and what was the most discomfort?
I'm not sure if I would say it's really discomfort, but to piggyback on what Hazza said, is that I think during the launch of New Shepard, we don't wait 3 hours, but we wait about 2 hours, right? And the expecting the unexpected is what you need to be prepared for. That's what they don't teach you in training. They don't teach you in training. We went into a hold, I think it was 8 minutes before launch, and they don't teach you to prepare for a hold. Mission control doesn't tell you how long the hold is. They don't prepare you. So I think it's very important to, make yourself comfortable that the unexpected can happen anytime. It's not just during the flight profile. It can happen before, it can happen after. The landing definitely is like a truck, like he mentioned, but you're very happy because there's nothing worse that can happen after that. You're already on the ground. So no matter how hard it is, you're back to Earth. So, and I think the most unforgettable memory would be, piggybacking off of this, is you train for so many things, but it's not the exact same in the actual, when you're experiencing it. When in ascent, the rocket goes up and then it turns and it tilts and it's on a trajectory. But the simulator doesn't do that. The simulator is just there to simulate what's happening. But when you're actually there, I felt for a second that I was falling out of my seat. Because you never realize how big the angle which it's tilting at is. You're busy looking outside, you want to enjoy the view, you want to do all this, but there's so many other things happening, and I think that itself is beautiful. You have to want to enjoy it. And you said you have to have fun. If you forget to have fun, I don't think you'll remember the best moments. You're going to try to remember what was nice, rather the whole flight being nice in an entity itself. So.
Thank you. Alpa, did you want to add some discomfort and unforgettable moments?
Not about the discomfort, actually, because what we call discomforts and what might be taken as a discomfort in many's mind is actually a nature of our lifestyles and background, what we have been doing in the aviation as well. So when we don't take it as an area of risk, when we don't focus it to get ourselves stressed about it, you start to enjoy. Because mind and the body reflex is already prepared and constantly making, all these iterations in the mind to be ready for the unexpected. However, psychologically, you are ready to enjoy those first moments that you will experience for the first time in your life. And I remember the very first moment that I unbuckled from my seat in order to prepare the cabin for the operation, right after the launch. And after I completed what I was supposed to do, I immediately started to use the 3D dimension, to start enjoying the 3D dimension and the freedom of being able to move inside the space. And I remember the very first sentence that Michael uttered. He said, I think you already forgot, you already missed doing aerobatics in an aircraft. So it's an amazing, moment. And anything that you enjoy over there is already dominating what could be taken as a discomfort. So I always tell that whatever a playground for a child is, the space is the same for an astronaut. Thank you.
So you're all grown-up children. I have one question here, which I would like to address to Ethan. Did your journey to space provide you with any new perspectives, and how has it affected your daily life?
It has affected my daily life. What was the first question?
Well, whether space flight, the journey to space, provided you with any new perspectives.
Okay.
And so how it has impacted your daily life.
But my personal life was affected in a way. Before I was very deeply involved in impact investing in developing countries with a venture capital investment fund. Then I stopped that completely, moved to Houston, started training about a year and a half, deeply involved in preparation for the mission and all the content of it. And then I came back, got used to gravity again, went back to the office, and found that everything is perfect without me. So so I didn't go back to business, basically. I continued getting more and more involved with Rakia team, developing this outreach potential of using space as a tool to attract and to inspire next generations and research and philosophical thought groups of how and whether, and is humanity restricted to Earth? Is this vision of bringing or reproducing humanity on another planet feasible? So these are very questions that I deal with today.
Thanks, Ethan. Mike, I think you're the only one amongst all of our distinguished panelists here who has not only done an EVA, but who is a record holder in EVA time. So I have one question here for you. What is it like to do an EVA, to be outside the station?
Fantastic. I'm going to go back to the previous question, or my answer to the question about what my advice is to first-time flyers, which is to enjoy yourself. That is even more difficult when you're doing a spacewalk, because if the timeline inside the module is very tight and strict, outside it's even more so. We have a very limited amount of consumables, meaning the duration of the EVA cannot exceed a certain time, and we have a long list of things that we have to do in that time. So it's hard to combine the fact that you are a human satellite going around the Earth at 8 kilometers per second, and you're trying to drive a bolt with this glorified cordless screwdriver. I mean, these things they clash a little bit, and it's very difficult to think of both at the same time. So unfortunately, you spend almost all of your time thinking about driving the bolt and not about the amazing view that however good it is from inside the space station or in a suborbital flight, it is that much better when there's nothing between you and open space but this very thin polycarbonate visor. So the one time that I did get a chance to enjoy it, we were doing a test of this device that's attached to the backpack, which an astronaut would use to rescue themselves in the case that they were somehow detached. We're always attached to the structure with a a steel cable. Somehow that cable broke, or if you failed to attach it properly, however unlikely that is. In the old days, the shuttle, when we did spacewalks from it, could basically go chase you down like driving a car to pick somebody up. But the space station is too big to maneuver like that, so we have to figure out a way to get back there. So this device has some thrusters that we basically drive ourselves like a jetpack. And we were about to do a test of that, but we were waiting for some lighting conditions because it had to be filmed. And as we came up over Mexico from the southwest to the northeast, we came up over the Caribbean, and I was waiting to be released by my crewmate who was attached, had his feet restrained by the robotic arm, and he's holding me, and we're ready to go, but we have to wait. So we have basically nothing to do for 3 or 4 minutes except look around at the view. And of all the places on Earth, I think one of the most remarkable is the Caribbean, with the colors of the sea, especially close to the islands where it's shallow and you see the greens and the blues. It's spectacular. And this image is really burned in my head, and that was the one time that I could really enjoy that magnificent experience of being outside the spacecraft.
Well, thanks for this exciting insights. I have another question that goes a bit in the direction of your cooperating with the support of robots in space. Interstellar, the movie, showed an interesting dynamic between the astronaut and an intelligent robotic assistant. What are your opinions on something similar in real world? So how far are we already to think that robots can assist astronauts in space? Who wants to take this one? Hazar.
I can think about a couple of experiments on board the station, like Simon. It is the ESA experiment. It's related, there's a floating robot that it's more psychological, interacting with the astronaut. It's still under experiment. There is another one from JAXA. It's Intpol also. It's floating robot on board the station. And also Astrobee is another one. So all of these are like experimental, like things that they are doing on board the station currently to explore how we can use robotics on that aspect. Other than that, there is when you say robotics, there is different way of looking at that. Like the Canadarm which is outside the station, that grab a couple of vehicles, or helping us when we are doing EVA as I would say third arm, or like moving us from different places to another place outside the station. And if we think about it, in future we need more autonomous, more I would say AI implementation to these type of robotics, so that we can focus on something else while the robotics can give us more help without interference with the humans. So yesterday actually I was visiting one of the universities here, IIT, and they show us a lot of things that are really amazing in terms of how they are using robotics implementation on that aspect. So that was really amazing to see here in India, and I think that is something that we need to implement more in human space flights.
Thank you. I have another question here that goes in the direction of comparing training programs between the established programs of NASA or Soyuz training versus training for private missions, for commercial missions. Maybe Mike, you can give some, and then also maybe Shirisha or Gopisham from your perspective.
Yeah, so I had the privilege of flying on Soyuz, and for that, and for the long duration mission on the ISS, later I spent about 1 month in Houston and 1 month in Star City, just outside Moscow, for about 2 years. So I spent, like Hazak, quite a bit of time, and Rakesh, of course, in Star City. And I would say there's a quite different philosophy toward training between the two systems. I would say the Russian is much more theoretical, how things work from a very design perspective. I remember, this is a sort of an anecdote that American astronauts share with each other, that they actually taught us how a relay worked. And the American approach would be, I don't really care how the relay works. All I care about is when I flip the switch, something happens. So it's a little bit of a different philosophy in terms of the depth of knowledge. Now, I think that if you have a lot of time, the Russian approach is quite thorough, and you really understand the fundamentals of how things work. The NASA approach is much more practical, so we do a lot of simulations. We interface with the machine more as a system rather than component by component. And I think it also reflects a bit, it won't surprise you that the Russian system is a bit more centralized, where mission control makes a lot of the decisions and the crew are expected to execute those decisions sort of without thinking too much about it, whereas on the US side, the crew has a lot more input into how procedures are written, how the timeline is produced. So, you know, each of the programs is very successful, and both have a lot to be proud of, but the approach is somewhat different.
May I add
Thank you. Yes.
difference between the different entities that we trained in? We trained a lot at NASA, which is a big organization, computerized, lots of books and papers and tests and exams. SpaceX is paperless, so you train there only on computers and hands-on. And then you go to ESA, which is a very, very multicultural. You have to adjust to different accents, Italian, German, French, of the instructors, but it's a very open environment, much more than NASA. Just for example, when you go to the SpaceX repair of the Dragon systems, 4 nationals wear a different color cap so the cameras can see where these spies are walking around. So very strict in the US, and in Europe we found it much more open. In Japan it was very efficient with the Japanese JAXA, with a special phenomena that after you complete the exams and everything, destroy everything. So we had a lot of experiences, and with Axiom itself, because we were the first, they were very flexible. They were trying to adjust and adapt to all the requirements of all the crew members coming from different environments, and they were building the capacity to support different desires of new astronauts.
How does that compare to New Shepard training?
And then you have the other side, which is weekend training. But I honestly think that we're already there, if not yet. But it will entail that somebody was asking me that, do I have to do engineering or do I have to do physics to be an astronaut? But the generation that we live in today, you don't need that anymore, right? You have autonomous vehicles, you have all these guided systems which does everything for you. Whether if it's suborbital, I don't know how long it will take to go to something like this, to the ISS, or orbital flight. But I was talking to Jared Isaacman, who you know, with NASA, and he was describing that we in this decade will achieve at some point a non-educational engineering background candidate to be able to put on a rocket and strap him and take him up there because of the technology and everything that's advanced today. And for that, the training that is required is more, I would say, psychological than physical. You don't need to be a fighter pilot. You don't need to be a pilot, forget fighter pilot. You don't need to have all the maths and the physics that from birth, you know, you've been drilled into, oh, if you have to go to space, you have to be A, B, C, D, E. It's not required anymore. I don't think it is. And I think that we will see, this generation will definitely see autonomous flight, completely autonomous flight, whether if it's to the ISS or not, but very close, right? And I think that that's important to realize that how much we have advanced in, a little over 100 years from the first flight, right? So from the Wright brothers, which is incredible, which is really incredible. And if we've come so far, most of it in the last 2 decades, then the next 80 years is just a cakewalk, is what I see. So.
Well, thank you very much. We are running out of time, but I don't want to, I have still a lot of questions, and I'm sure you'll be still available also for the autograph session this afternoon, where people can ask you some questions. I would like to finish with a quick lightning round and ask every single of you to, because we are here at the Space Exploration Conference and we've asked these questions to others, finish the sentence. The future of space exploration is... Who wants to start?
Bright.
Bright.
Here.
Shirisha.
It is here.
It is here.
Exciting.
What?
Exciting.
Exciting.
It's collaboration.
Collaboration.
Is all about accessibility.
Accessibility.
I would say together.
Together.
I think it's going to be cultural.
Cultural.
The future is beyond the sky.
Thank you very much. Please give a big applause to all these distinguished panelists. To ask you to come in front to do a group picture. Ladies and gentlemen, if you can please already again take your seats as we are without any further break moving to our second GNF session of today, which will also be a very interesting and exciting discussion. So please take your seats. The next session of today is titled Galaxy Forum, International New Space to the Moon, and this is organized jointly by the International Lunar Observatory Association, ILOA, Steve, and the International Lunar Exploration Working Group. And we see Bernard here. It is my great pleasure to welcome on stage the moderator of this session, Mr. Jatan Mehta, space writer and author for Moon Monday. So, Mr. Mehta, thanks for being here, moderating this session. The floor is yours. Thank you.
Hi, everyone. It's great to be here, and it's my pleasure to be moderating this fantastic panel very soon. I would like to thank the IAF for organizing this wonderful conference. I would like to invite my wonderful panelists on stage. So when I take your name, please come above. Steve Dust, Director of ILOA. Welcome. A round of applause, please, from the audience. Pascal Arenford, President of COSPAR, please come above. Bernard Foyng, Executive Director, International Lunar Exploration Working Group, and both of them stellar space scientists, Pascal and Bernard. Tanya Masons-Wan, space lawyer, acclaimed space lawyer. Welcome. Gaurav Seth, ex-ISRO, as well as the CEO of PeerSite, a private space company in India. Please get seated. It's always going to be tough following up on an astronaut session, but I'm more than confident in my stellar panel that they'll make it worth your while. So let's get started. So I would like to get started with an icebreaker. Before my panel introduces themselves and the excellent work they are all doing in their respective fields, I would like to start with an icebreaker for the, for the crowd here, because we just had an excellent astronaut session, and we know that this decade we are aiming to put astronauts on the moon. Both the US and China have plans to land astronauts before 2030. So I would like to have a quick show of hands from my panel as well as from the crowd as to who do you think will land humans on the moon first this decade. Of course, both of them will, and that's going to be amazing. But who do you think will land humans on the moon first? Will it be the Chinese or will it be the Americans? Steve?
Well, the way things stand now, it looks like NASA in America is looking for 2027, 2028. I would imagine my own gut feeling is that the two countries will land their citizens within a year of each other.
Yeah, so we have heard actually, yesterday from all the different programs, there are deadlines. In that, currently NASA leads, in the time schedule, but we have to see that lunar missions, they are very, very complex and they might have delays, and it is always possible that it will be shifted. But I think we wish everybody well, and we want that somebody succeeds. It will remain competitive.
My baby landed on the moon in 2006, but it was a robot. And it was the first of this millennium. But I think humanity will land on the moon with all of us. And we have all friends in Asia, in America, in Europe. And it will be, I think, a benefit for all of us.
Of course, the Americans were the first. China is going very fast. I had the privilege of visiting a few months ago, and I was deeply impressed. But I would say I hope it would be a joint mission, Americans and Chinese at the same time.
That'd be amazing.
Yeah, I think I agree with Steve that both countries would be very close to each other. I don't know which one would be first because engineering is complex. But something I wish for is humanity lands on moon this decade.
Amazing. Can we get a show of hands from the audience? Who do you think will land first? Will it be the Americans? Can we get a show of hands, please? Okay. Okay, I see quite a few. And what about, will it be the Chinese who will land first? Okay, so more people, I think I would include myself in there. So I think more people think that China will land humans on the moon first. But regardless, it's going to be amazing to have both of these countries land humans on the moon again so that we can explore further and farther than ever before. All right, so I would allow all my panelists to introduce themselves and give us a good sense of their work, because all of them are coming from deeply different backgrounds. Yeah. So I would like to start with Steve.
Thank you, Jayton. I'm Steve Durst, the director of the International Lunar Observatory Association based in Hawaii, on Hawaii Island. The purpose of ILOA is to expand human understanding of the cosmos through observation from the moon. ILOA has a number of moon missions. Our flagship, ILO-1, which we've been pursuing for a number of years, has a number of objectives. The first one is to take the first image of the Milky Way galaxy ever from the lunar surface in this century robotically, and then to expand astronomy from the moon, a new frontier for astronomy with invited astronomical observations by leading astronomers and observatories around the world, to advance independent enterprises, and to conduct our second main function after observation, which is communications, first scientific and then commercial. We also have Earth observation as a growing important function of observation from the moon, and also lunar base build-out to be a part of that phenomena. We have conducted, we have a number of precursor missions. One conducted last year on the first lander by the USA in over 50 years. Intuitive Machines 1 carried a number of NASA and independent payloads, including our ILO-X experimental two cameras, two small telescopes, which did get some great imagery on the way in, a few star trails, picture of the sun from the lunar surface. So that was completed. We gained a lot of information. The landing was off nominal, but there's still many benefits. We have software assets on the moon that we haven't even begun to utilize, including our Space Calendar Weekly. ILOC, which proposal was accepted by the Chang'e 7 China National Space Association for one of the international payloads to launch next year, I believe in August, to the Moon South Pole, which has always been our interest and destination, the Moon South Pole. Your Professor Rao was a founding director of ILOA, and on his own initiative traveled 3 times from Bangalore to Hawaii to learn and contribute to our focus at the Moon South Pole. So we are very happy to see India achieve the first mission to the South Pole region. ILOC is a consortium of 4 partners at this point. Our ILOA, our longtime partners at the National Astronomical Observatory in China, are also long-term partners in Thailand with NARIT, the National Astronomical Research Institute of Thailand, and more recently, Hong Kong University. Finally, these initiatives, independent initiatives for communications, observation and communications, we hope contribute to the dialogue that our affiliated space age publishing company and ILOA Galaxy forums, such as this one, are considering. A big picture, here we are in 2025, 1/4 of the way through this pivotal 21st century. A great time to take stock, look ahead, be ambitious, optimistic about what we humans can do in the next 75 years with our resources and wise application of our ideals. I happen to think, and I think this is a challenge for space agencies, not just NASA or ISRO or the Chinese Space Agency, but all the space agencies, universities, think tanks, aerospace corporations, to take a good look, what comes next. In India's case, 2047 and 2040 on the moon, but how about 2050 or 2075? And I really believe that the human destiny in the 21st century will be decided in the Jupiter and Saturn systems, where 90% of the solar system mass, planetary mass, is located. So it's this big vision that our entrepreneurial, independent efforts, I think, are part of a larger picture that will expand the dimension and the sphere of opportunity for individual achievement. And those are my introductory remarks, Chetan. I hope I didn't take too long.
Thanks, Steve. Pascal.
Yes, good morning and thank you for inviting me here. I'm Pascal Ehrenfreund, the president of the Committee on Space Research, COSPAR. And I just want to take a little bit a different approach. We have heard a lot, in particular from space agencies, about their programs also in the next decade. But this is an example from BryceTech published last year about the missions, the moon missions in the following 10 years. And so these are more than 150, and you can actually download it somewhere on the internet, that you see how many countries are involved, how many commercial actors are involved, how many space agencies involved, and that really looks at missions going to the cislunar region, but also, of course, to the surface on the moon. And that makes you think this surge, you know, of renewed interest in the moon and how we are going to handle it. So I just want to say that COSPAR, the Committee on Space Research, was founded in 1958. And it was actually the first organization which was granted an observer status in the United Nations Committee on the Peaceful Uses of Outer Space, UN GOPUS. And here we work very, very strongly with the United Nations committees on planetary protection and space debris, mission planning, defense, space weather, and many other subjects. COSPAR covers all space disciplines and has 14,000 associates. And in that kind, we actually really are looking also at sustainable space exploration activities and looking at this enormous surge of missions, which will not all reach the moon, obviously, but are in the planning at the moment. We are also working with a lot of other organizations like the World Economic Forum, and this is an article we published for some of the important measurements on sustainability for space exploration activities, in particular for the moon, that we do not have really environmental databases. We don't have anything comprehensive. We have to align the space stakeholders, and I'm sure we will discuss that in the panel, in a dialogue, so that they exchange knowledge. We have to drive a consensus building on harmful contamination. It is something which is not agreed upon. This is a very important subject. We're getting data on the moon all the time. We have to incorporate the scientific research into policies continuously. We have to be more transparent. We have heard interoperability. Imagine you have two, we will come back to that. I think, imagine you have two companies and they want to land. They need to have a safety zone. They want to land at the same place and more or less do similar things. How do you handle that? So coordinate regulatory mechanisms, and we have actually an expert on the panel which will look at this, certainly explain it. And public awareness, we have just seen that in the last panel, how important that is. So I just wanted to think this really incredible surge of missions in the future. I think we have to address also sustainability.
Thanks, Pascal.
Thank you. So fasten your seatbelt. We are going to the moon all together. And so we started already 30 years ago when we created the International Lunar Exploration Working Group, ILWIG, between agencies, but also open to academia, industries, explorers. You are all part of it. And ILWIG reports to agencies, but also to the COSPAR commissions and also the panel on exploration. And in 2001, we created also a society of lunar explorers worldwide, where we can get some money, so you can donate, but we got also grants, we can monitor activities, we have events, we have research grant, and we have a special Young Lunar Explorers grant in all disciplines, from science, technologies, even space diplomacy and law. So how do we implement new space? Because that's about new space, this panel. We do new space, new technology, new AI, machine learning applied to data analysis, new technologies, miniaturization, of instruments, cooperative robotics. We also started a program of CubeSat. We do also new space in terms of, we managed to get money. We got commercial partners paying us to deliver them some research services. We got grant from EU, we got grant from space agencies, from universities. And we go in the field to really test things like we would be on the moon and Mars. So we go on volcanoes like Etna, we go to Hawaii, nice places to train to go to the moon. But we also developed a special training academy for our researchers, our astronauts, our business people, and we try to train the next generation, not only in science, but also in being innovator and making business. And another activities, we try to develop space as a place for peace. So we have space for peace, and we have also space renaissance for all. So already in 2010, we were into commercial lunar exploration. We built, together with some of the Google Lunar X Prize team that wanted to win $20 million, we built some small lander to test how to deploy instrument rovers on board. So we tested them in the stack. A small instrument was the Akuto rover, which later led to the company iSpace. So they grew much more than I did, but we were part of this group of 20 competitors for Google and X Prize. And then we tried to test this instrument in the lab, but also in the field. So we went to Etna, a volcano, so together with the German Aerospace Center, ESA, we went to Utah, Mars Desert, we went also to other places, Atacama, and now we have access to a number of bases, and we are running one base, which is in Mauna Loa volcano, called IC. But we went also to many places, and we want to go to all continents. 4 years ago, we made also a proposal to the European Commission to get money to train space entrepreneurs. We got the money, but we use it to train them together with space researchers and with astronauts. And these are some of our partners from universities, but also companies that are involved in this Euro Space Hub. And in this part, we also created a new curriculum in collaboration with some universities to train the next generation of space explorers in science, in technology, in humanities, social science, also in management and business, and we continued also the training in hands-on astronautic activity, which should be done for everybody. So one example of business we have developed is applying AI to Earth observation data, monitoring cities, but we do that also for other exploration domains. Another commercial activities, we have been involved in some payload on some commercial landers, and now we have got also a collaboration with Cosmosis, a lunar lander company that pays us to deliver some science and research service. So we act as chief scientists for Cosmosis to develop payload for lunar landers and for quantum satellites. More recently, also, we developed a collaboration with Space Renaissance International, a foundation to develop also all the humanistic aspect of going to space. And we propose, we are observer as well at the United Nations, like COSPA, and we propose to have Space Development Goal 18 dedicated to space for all on Earth and beyond. And we have now more than 130 organizations that endorse these activities. And as also a concrete action, we even developed a payload we are going to launch in June to celebrate Space Renaissance for All. It's a gallery where we are going to expose scientific samples, some biology, some plants, some seeds, but also we'll have 10 artwork celebrating space. And we have also some logos of 40 organizations, including IAF, COSPA. We have the UN flag to celebrate who are the main actors in this new ecosystem of space. Thank you very much.
Thanks, Bernard. Tanya?
Thank you, Jatan. So I don't have any cool pictures to share because I am a space lawyer, and I can show you a picture of the United Nations treaties booklet. And you know, when I became a space lawyer, actually at the beginning of my career, after having studied international law, it was really a weird profession. People said, space law, what is that? Does it exist? Nowadays, it's not so exotic anymore, and that is actually really good. It is now part and parcel of any space mission that you have to pay attention to the legal and the policy and the regulatory aspects. And so we have developed a body of law and a body of treaties and soft law, as we call it, of rules that govern activities in outer space. And in all of these instruments, you will see the term the moon and other celestial bodies, which is interesting. This panel is about the moon, and the moon is also really singled out in those international legal instruments, which is special. It's the only celestial body humankind has set foot on. It is the one that everybody, if the weather is good, sees from everywhere on Earth every day. It is part of the Earth-Moon system. We are part of the Earth-space system. The moon, in some cultures or religions, has a very special place. And so the regulation for our activities on the moon, I think, is really important. And several states, a handful of states, or a little bit more than a handful of states, have been to the moon. But I think, Pascal, you mentioned also the other day that there is, what, 150 missions planned, and so this is a sea change that we're going through at the moment in this new space era with private companies going to the moon. So how are we going to regulate that? And regulation not in the sense of stifling or bothering them or annoying them with rules, but also facilitating their ambitious plans. And some of those plans may be great, and some of those plans may be less great. Do we want a Coca-Cola billboard on the moon, or ashes spread over the moon surface, or do we want to protect certain the footprints of Neil Armstrong? Do we want to, well, whatever we want to do, we will have to find ways to regulate that. And those rules that I mentioned, they are for states. And so the big issue will be, and I'm sure we will be discussing it perhaps later, is how do we make sure that those private entities also are part of that regulatory ecosystem. And so that is my mission. I teach students. I see really an increasing interest of the young generation in legal aspects, and I particularly applaud also students from STEM areas, so the science and technology and math, who are also interested to learn about this. And I think that is really also important, that we have interdisciplinary approaches. We should not all be on our island, on our silo, but we have to consider all these aspects of space exploration, including the legal ones. Thanks.
Excellent. Thanks, Tanya. What is space but interdisciplinary, right?
Sorry?
What is space but interdisciplinary at the end of the day?
Exactly.
Yeah. Gaurav?
Yeah. Thanks, Jatin. Thanks for having me. Hi, everyone. I'm Gaurav Seth. I'm the CEO of PeerSight Space. We are a new space startup building Earth observation satellites for persistent ocean monitoring using synthetic aperture radar and AIS sensors. Before starting PeerSight, I used to be a scientist at ISRO, and probably why I'm invited to this panel. So during my time at ISRO, I worked on the Chandrayaan-2 mission on the dual frequency synthetic aperture radar, as well as the proposal for LoopX mission, which was going on during that time. And I must say that my experience of building planetary science payloads has significantly inspired the designs of our company as well.
Excellent. Thank you. So thanks for all the introductions. I would like to start with some of the interesting themes that we are seeing in modern lunar exploration. So when you contrast the Apollo era and the Soviet era of moon missions, you had these missions being mounted by primarily two countries, but now we are in a very different setting where not only the space superpowers are having missions to the moon, but you also have many countries mounting their first lunar missions, and they are being done in very different ways. Some are going as commercial payloads, some are going as government-enabled commercial payloads, some are going as a purely scientific symmetric payload, and then you have all sorts of collaboration, symmetric, asymmetric, cooperation, and so on. So I would like to start with Steve, because as he mentioned during his opening introduction, that he has already sent ILO-X camera payload on the Intuitive Machines IM-1 mission. And they are about to send ILO-C on Chang'e 7. And those are two very different entities that you get to work with, right? One of them is a US commercial entity, or US private lander entity, and one of them is a Chinese National Space Agency, right? So tell us, Steve, how did those arrangements come about, and how do you see this as being a distinct way to fly payloads to the moon? Because I'm sure that 20 years ago this probably would not have been possible, or would have been done very differently. So tell us about your experience and how did that come about?
Well, we've been pursuing this for quite a number of years. ILOA was founded in 2007. I think the advent of the NASA CLIPS program opened up opportunities for different kinds of companies and different kinds of experiments. Art, which was mentioned by Eitan previously, archives, data centers, many opportunities, including astronomy, and communications, which will follow astronomy. So with the arrival of the NASA CLIPS program, we were able to choose amongst a number of carriers, and did have an agreement and a contract with Intuitive Machines, and they have a number of additional missions also assigned by the CLIPS program. So there are widening opportunities now, and it's not just Intuitive Machines, there are a number of companies, and I made that argument or advocacy to China that China may do well with some kind of a PPP, public-private partnership, CLIPS type arrangement to increase the number of landings. In the case of the long-time collaboration that ILOA and our affiliated Space Age Publishing Company have had with New China, we saw that opportunity. We made a proposal for Chang'e 6, which didn't go to the South Pole, where we're focused keenly on, as are many other agencies and enterprises. But we did get selected for Chang'e 7. It's been a very interesting story forming this partnership because of certain difficulties collaborating with our longtime friends and partners in Canada who were not able to fully collaborate with China. So the ILOC mission is still evolving. We have a developing dynamic partnership with Thailand, which is exemplary for astronomy. So different approaches, Jayton, with both USA and China.
Yeah, thanks. I would now like to ask Pascal and Bernard about their experience with space science missions, and how do you think that plays into this modern context where private and commercial lunar landers do carry a lot more volume of science instruments to the moon now than in the past couple of decades. But at the same time, they have their own, not only they unlock possibilities, but also they have challenges, because the primary goal is dictated by their own needs and own purposes. So I would like to know from you as to how do you see the kinds of science that is now possible and within the timeframes that was not possible before. But at the same time, what is the kind of control that you don't have as a PI on a mission that is going to, let's say, anywhere on the moon? You may not have probably control over the landing site, or you may not have enough control over the operations. So I would like to hear on, what are the kinds of scientific enterprises that have opened up from private missions going to the moon, and at the same time, what are its challenges?
Well, I start in the positive way, that I think, as we have seen how many missions are actually in preparation or in the planning stage, that this is really a boost for science. At the moment, all these kind of small landers are taking a lot of instruments on board, and I think it provides a lot of payload opportunities which are also low cost. So right now I see it as a really positive thing, in particular because in the GLEX program and so on, it is still overseen by space agencies. So it's not yet completely a lone commercial. So I think it's a perfect situation. Obviously, scientists have to adapt to the situation and to the configuration of the spacecraft and so on. But I think everybody's happy, and in particular the low costs offers more possibility. And I just want to say before I give it further to people which are really built instruments or flew instruments. It is very, very important to explore the moon. It is, as I said yesterday, a part of the Earth. And even if you want to land and do in situ resource utilization in the future, you have to understand where you are going, what your environment is, what your mineralogy is, in order to plan a very, very good mission. So it is in the interest of all commercial players in order to work strongly together with science and research organizations and space agency in order to look at the lunar environment. We want to bring humans, to the moon. We want to build habitats. We have to understand the environment of the moon. And the science is really, really important.
Thanks, Bernard.
Yeah, so I come from old space. We call it legacy space because but now we became younger because we are going into new space. But the virtue of the legacy space, it has developed some technologies, and most of the new science results have unveiled new faces of the moon. They come from government programs so far. Also from program funding very interesting payload for the moon and also for planetary destination, for solar, space, weather, and so on. And they were really developed with government research funds. So we have to continue to fund fundamental research and all this. But now we have also the opportunities of going to the next step, and it will be partly for science, but also it will be for developing technologies that we need and knowledge that we need for the next step of working and living on the moon. So where we will need to develop life support system. We want also, because we have resources available, we want to learn how to harvest some of these resources. That's solar power. We found ice on the moon. I have estimated 1 billion tons of ice, which could be collected on the top 2 meters. And we don't want to use it all, by the way. And don't drink it, because it contains some cometary compound, like cyanide and others. You have to filter it. But you need also to learn. We can also do science from the moon. It's a great platform. And like Steve, he has put a small telescope to observe our galaxy. We could have access to the dark ages of the universe. And that will require big facilities. But at the moment, making benefit of this transport program, which was developed at the time of Google Lunar X Prize. Some of these companies then became the big one that got contracted to develop the CLIPS. We will be able to also put some larger instrument, and then we'll have Starship that can put 100 tons. So then we can be prepared for very large facilities, but it's also very important that creativity doesn't come only with big things. You need also to have the challenge of doing innovative concept. So it's good to have an ecosystem where you have both small research and also large facilities. So there are potential, but they still are to come. And we need also, in parallel to the supporting the human program, continue to support the research and fundamental science to make good use of this opportunity of emplacing a moon village.
Absolutely. Thanks a lot for those perspectives, Bernard and Pascal. The moon is a scientific bonanza, and and ultimately at the end of the day, I believe what you're trying to say is that if the entire academic community thrives, it's then when we know that we are exploring the moon the right way, scientifically, right?
And also, it's not only for the scientists. You need a scientist to help characterize the environment, the condition, and this will help all the other actors. So if you have a commercial program to the moon, earmark 10% of the budget for the scientists. You can employ them to do work for you.
Absolutely. Thanks. Tanya, I would like to turn it over to you now. So with Steve, we talked about how in this new age of moon missions, we have possibilities of flying payloads in different ways than before. But there's also the flip side to it, which is you could also see, as you mentioned in your opening remarks, you could also have payloads that are not necessarily flown responsibly, or even if they are flown responsibly, you could always have accidents. We all know here that moon missions are extremely hard. There will be crashes, unintended crashes. So we just had Ashes being flown on Astrobotics lander. Thankfully, it didn't crash on the moon. But in the case of Space Isles lander, it did crash on the moon. And so we had payloads there which were carrying life forms. So with the cluster of moon missions in the South Polar region to be expected, and with private entities also there, as well as national missions ongoing in parallel, how do you think this is supposed to be managed from the perspective of sustainability, and also from the perspective of keeping everyone informed vis-a-vis the UN? And what I know, there have been some discussions that you mentioned that the UN has been having on space resources as well as on coordinating the actors. So could you please paint us a picture of what the challenges are and what role should be played via the UN, as well as what the actors should be cognizant of?
Yeah, thank you. I think that is a very important question. And indeed, we're going to see that mix of actors, right? It's not only the US and the Soviet Union, it's now states and entities, private entities, perhaps even individuals later on who will want to live on the moon. And of course, the moon is you. The moon is big. But there are certain areas that are favorite, right? Everybody wants to go to the poles because we know that there may be possibilities to sustain life there. And so there will be a need for coordination. In space law, the system is really built on supervision by states. It is all law that makes states responsible for national activities, including activities by private entities, and also liable for damage. So if a private company would indeed cause damage because it uses nuclear power or dangerous instruments or raises up dust, and the dust gets into the machinery of an expensive state mission or whatever, it will not be the company that will be held liable who can receive a claim, but it will be the launching state of that company. So the question of oversight is extremely important in the sense of supervising those national activities, which makes the licensing systems and the authorization and supervision, which are state obligations, and we have 115 states that are party to the Outer Space Treaty, and you could even say it's customary law, it's binding on everyone who would like to go to the moon, because it has been in existence for nearly 60 years. You will have to find ways to implement that into national law. And how states do that may differ, because states have different policies. One state may want to attract space business and accept maybe crazy missions, and another is perhaps more interested in sustainability or in ethical matters or whatever. So we do not have a guarantee that these regulations governing the private companies will be harmonized. And that is why I think the role of the United Nations is essential. We see, of course, things happening with agreements being concluded, whether it's Artemis Accords or ILRS, where certain principles are adopted. But it remains essential to have that coordination in the United Nations, which also has set up an action team for lunar activities coordination at LAC. And that is an initiative that was proposed by Romania. And that is, I think, important. And you see that states are interested in cooperating in that. Why? Because it's also in their interest, right? Because your national law may be governing the activities of your private entities, but it will not protect you against activities of a company of another state or another state's activities. So even though we have these national laws or regional cooperations, that global concertation, if you like, or coordination remains essential. And so that is why even though sometimes you hear the United Nations and COPOS, it's slow and it's not making any treaties anymore, and we even have a moon treaty, but it's the first and only treaty for which a state actually resigned. It withdrew. So that is, of course, a worrying scenario. But overall, I think that we should really cherish that multilateral diplomatic forum for coordination.
Thanks so much. I would like to have a quick follow-up on that. You mentioned the Artemis Accords and the ILRS programs respectively. There's Thailand, which is a common entity to both. And so what role do you think, in the context of everything you said, what role do you think that the UN could make in enabling dialogue between these two camps, which are not necessarily opposed to each other, but at the same time have fewer common entities? So I think the more the merrier, right? So how do you see the UN playing a role in enabling that sort of dialogue?
Well, I would actually hope that there will be more states who will sign up both to the Artemis Accords and to the ILRS cooperation, because I believe in essence they are promoting the same principles, which are the principles that are enshrined in the Outer Space Treaty. And of course, in Artemis Accords we have the set of principles, we have it on paper, we see what it is about. For ILRS, we do not really have yet an instrument that is made public, but I know that the common principles are quite similar. And the UN is taking all these principles, just like the Hague Working Group, I was one of the founders of, which established 20 building blocks for space resource governance. All these instruments are input to the UN, because of course UN COPOS as such is only meeting two weeks a year in the legal subcommittee, and they don't have time to think about all the little nitty-gritty. And so they will use those inputs of regional or national or whatever developments there are, where people have been thinking about what should we include in such a system, and then take that and mix and match and hopefully come out with some common denominators that everybody can agree to. And so, yeah, these are steps, building blocks towards global agreement. You cannot expect, I think, at the UN level to come up with a treaty on space, on lunar governance from scratch. So we should see all that as components towards global consensus.
Thanks. Gaurav, let's come to you. What I would like to hear is your experience with the Chandrayaan-2 orbiter. So for the audience here, the Chandrayaan-2 orbiter has a very elegant radar system which has been not only mapping water ice on the moon's poles, but also has been actually involved in Artemis landing site selection work. So there's been active collaboration between ISRO and NASA on that front. And Gaurav here has been involved in the engineering of that instrument, as well as several other associated missions. So what we would like to hear from you is what was it like during the conception phase of the Chandrayaan-2 orbiter mission, and during the development part, what were the challenges you faced? If you could highlight a particular one which was quite important, and how you overcame that, because the instrument has been clearly doing its job, and we would really love to know what went into it.
Yeah, so I mean, something very unique to imaging instruments is that they need to be very well calibrated before you can start generating geophysical parameters out of them. So one of the major challenges there was that lack of calibration targets on the moon. You can't send corner reflectors or stuff like that for the calibration. So we had to come up with a very unique strategy of ground-based characterization, where a lot of that calibration was smartly done on ground. And then we used the phase when we were around the Earth, cruising towards moon. We tried to take images over the Amazon and use that to calibrate the target. And then once we were at the moon, the mission also had a lander, so the image is also public. The instrument tried to image the lander, and we knew the kind of reflectivity which would be generated due to the lander, because it was our own hardware, and that was again used to smartly calibrate the instrument. So this was, if you ask me, one of the major challenges. This was one, and we could very well overcome it due to great work from the team, and because of which the instrument has been continuing to give great results. I think we are now in year 5 or year 6 and have ISRO has mapped all of the poles and is also doing non-polar targets extensively now.
Amazing. And it's quite interesting to me how the Earth has been used for calibration for the lunar instrument, and obviously Earth observation satellites use the moon as a calibration point for their Earth observation as well. So it's quite interesting.
As someone correctly said, moon is part of the Earth. So.
Yes. Yes, Bernard.
Yeah, just on this point of coordination of activities, for instance, this calibration of targets, at ILUIG, we started this activity under Carly Peters, so who became also PI of an instrument of round 1, and that conduct also PI on other mission to select a few targets on the moon that we would all observe, and actually we observe them with smart one, with all the mission, and then we could really learn about our instruments. This also coordination at the data level led also to a coordination in where you could put instruments from another countries on international mission, and Chandrayaan 1 was the most international mission at some stage. Yep. So congratulations, India, for that. And also, then the next step was to try to develop some vehicles with them. And so now we have the example of LUPEX, where you have two countries, one providing the lander, other providing the rover. So they are more and more collaborating, also at the level of the hardware. But we have also to develop some standards for communication, for navigation, positioning. And for this, there is a lot of opportunities for commercial service to be involved. Yeah. And this can be used for many missions of governmental origin, also commercial origin. So that's how this new lunar economy is now growing up.
Yeah, correct.
Yeah. Absolutely, that's very interesting. Thanks for that, Bernard. Now I would like to turn to the Europeans on the panel, and we would like to shift from a global perspective to a little bit of a regional one. We have heard over the duration of the conference as to how Europe has been recalibrating for their lunar exploration strategy. And I think that's an excellent move. We just heard yesterday that ESA and ISRO are collaborating on human spaceflight. But of course, there's also the question about the NASA budgets affecting Europe. So what I would like to hear from you guys is, drawing from your experience, what is one thing that you would like to see Europe do in lunar exploration that could give it a more independent stance and also contribute to global exploration of the moon?
Human spaceflight capability.
As well as robotic lunar exploration, but independently.
Well, yes, but if we want to be independent, or at least not too dependent on others, I think we can do much. And I mean, I'm not a scientist or an engineer, so don't quote me on that. But what we really lack is that capability to send humans into outer space. And if I had one vision for Europe, it would be to develop that, depending, of course, on the finance and the technical capabilities. But that would be wonderful.
Thanks.
I'm also short, Bernard probably will be longer. I think something what having been working, also on ExoMars for a long time, entry, descent, and landing technologies, EDLs, is something what has not been developed. There are a lot of gaps which has to be followed in Europe in order to be more autonomous. It is discussed now since 2, 3, 4 years extensively in Europe, not only by ESA but also by the European Union, that one has to be more autonomous and has to build up technological gaps and so on, but it is a very, very slow process. I think we are talking about that since 20 years, yeah? And because there are so many decision makers involved, yeah? And I hope that there is, in particular because of the geological landscape, that there is more the mindset going into this direction, like Tanya said.
Thanks.
In old space, 25 years ago, ESA was able to develop a mission to the moon in 3 years, smart one. A mission to Mars, Mars Express, also in 3 years. We developed a mission to Venus in 2.5 years. So we have all the technical ability to do it. Now some people say, oh, let's have a big vision for Europe, but vision without execution is hallucination. And if you put the vision and you delay it without really working with all the stakeholders, industry has to be involved to be competitive. So the management also, so like Pascal mentioned ExoMars, but we went in many directions in ExoMars. Initially, ExoMars was supposed to be an autonomous European mission to develop all these technologies. That actually we developed some of them, but then we had a collaboration with US that abandoned us. Then we went to Russia, with whom we worked very well, but unfortunately we got the conflict that stopped everything. But clearly, we have the means in Europe to develop satellites. We are very good. We could, entry, descent, landing. We had one probe that managed to reach the surface. That was Beagle 2. Beagle 2 went to the surface. Just could not work because its panel didn't open. But it went to the surface. And then we developed one probe 10 times bigger, 10 times more expensive, that didn't even reach the surface. So, we have to learn, but it's difficult. It's more difficult on the moon even to do soft landing. But we have the technical capability, but we need a good focus and a good technical and management partnership between all the stakeholders. And we need also some courage and some continuity into what we are doing. But we had a project of a lunar lander we could have launched in 2005. Now we have one big lander, Argonaut, which is planned for 2031.
Thanks. Steve? Yes.
Thanks, Jason. I have a couple of observations to share. One on the international approach to the moon. About a year ago, we started at ILOA focusing on a trilateral approach to the moon with India, China, and USA. Why those three? Because those are the only three countries that have declared their intention to send their nationals to the moon by their own resources. And by USA, I mean our traditional space station partners, Canada, Europe, Japan, Russia. And it's not a bad balance or bad trilateral symmetry, worth exploring. And here I'm so thankful that we're in this marvelous conference hall in incredible, independent, innovative India. So I think we can all take heart that it's not just between USA and China. India and Europe, as a US ally, are also keenly involved in this. On the entrepreneurial, independent, commercial side of things, one of the interesting observations that's been shared by Pascal and Tanya and Bernard, I haven't heard it quite so clearly before as here, namely that the moon is really part of the Earth. It's a two-world system. And that raises questions that here on Earth, we have private property. So how would that translate or be denied the same kind of practices on the moon if there are, part of the American dream is owning your own home. What about the moon? So international questions, including India, independent enterprise questions, including the similarity or the eighth continent of the moon. How does it differ in terms of human practices and development from what we've done on Earth? I hope there are differences, of course. And I'd like to also commend Tanya's hope that America and China and India and all collaborate together, even independently, but together. So that's a question. If the Earth and Moon are part of a system, the Moon is the eighth continent, why shouldn't Earth practices that are constructive, and say from a Western civilization point of view, where independent enterprise and private property are enshrined fairly high, that may be a question for the future.
Can I very
Tanya?
quickly respond? Because Steve, you know, you can own your home on the moon if you would want to. It's just that you cannot own the moon because no one is the boss of the celestial body as such. But objects that are in outer space are owned, and that is not, it's like satellites in the geostationary orbit. They are owned, but they are not entitled to a permanent place. They do not own the slot or the orbit. They have a using right, and that is the same. And sometimes even here on Earth, you have you have the right to have an object on a terrain, but you do not own the ground. So that's the only difference. And it needs coordination again, because there's no there's no sovereign state that can be the boss, so to say. But owning objects or a station or an installation is not prohibited. So again, that wonderful outer space treaty.
A short one. Also, I love the space treaty because it prohibits war. It prohibits weapons. So on the moon and other celestial bodies. So I want to keep this part. And no borders, but you could have also something like...
Has the treaty ever been amended, or could it be amended?
Yeah, it can be, but I think that the fact that you have no conflict of territories, it's an asset. And then you can have the model of Antarctica, where you can have a platform for research. Partly the moon can be there. You can have also the ocean, where nobody owns the ocean, but you can go fishing there. So you can exploit some of the resources. So you don't need to own the land or the ocean to have a very good benefit for everybody.
Okay. Yes, Pascal.
Well, in America, you own land when you buy the house.
So since we have less than 4 minutes left, I would like to end up with a quick but very important question. Speaking of the moon being part of Earth, but you know, I'm sure we all believe that here because we know its scientific importance, but I'm not sure if the public at large does. And even at the height of the Apollo program, it could not be sustained because public support wasn't there enough. And so this time when we go, we should make sure that not only do we go, but we have the public support to stay. And so just since we are short on time, but I would like to hear one thing that you think, each of you thinks that we should do to expand the public's interest, expand and invigorate the public's interest in lunar exploration. What is the one thing that you would do if you had all the power in the world? Steve?
Well, I just mentioned, let people have a little skin in the game. Independent ownership up to a point. If I can make a second recommendation, it would be what the Artemis program helps to do, to make the moon accessible for all people, the other half of humanity. I think when the first woman touches down on the moon, it will be the signature event of the 21st century to that time, opening up the moon to all of humanity. I don't think you have to go all the way to Mars for humanity to become a multi-world civilization.
Thanks. Pascal?
Well, I think citizen science and involving the society at large, this is what we're all trying to do. There has to be much more. And I think what we didn't mention yet, that's of course education and the education of teachers, you know, in order, you know, to create a generation which can actually be inspired and also work on the future of this new space exploration era.
Thanks.
Yeah, for me, it's the principle that we put for Moon Village. So all benefits the moon for all, or space renaissance on the moon for all, and that includes knowledge, science, but also developing technologies for the benefit of not only humanity, for the whole biosphere has to benefit, but also business opportunities, and developing also a new culture because we will be a multi-planetary species to take care more of the Earth, but also to prepare ourselves to expand life in the solar system with the values of exploration, but also the values of doing all together, like a renaissance, like in Italy, the Renaissance, but now a space renaissance for all the world.
Thanks. Tanya?
Yeah, I'm like Pascal. I also think that if I had all the power of the world, I would want all the governments to really do much more in raising public awareness about the importance of space exploration and specifically the moon. Education, outreach, we really need to up our game. There is not enough awareness of the importance of space for our life here on Earth in all its aspects that we have been hearing here for the past days. So.
Absolutely, Gaurav. I mean, if you want public support, be capital efficient is something I'd like to say in the entire exploration process. And the Indian space program has proven time and again of being very capital efficient while trying to develop complex technologies. And now with the private sector coming in, and the Indian space policy allows the private sector to even do interplanetary stuff. I think Indian startups and new space ecosystem can build for the world in a very capital efficient way in order to sustain all the curiosity and the scientific experiments people want to do.
It makes it easier to have public support. Yes, and we are just exactly on time.
Yeah, 0-0, we can always see that.
Thanks a lot to the stellar panel. A round of applause for answering all sorts of questions across a range of topics. And as the very last point, as a communicator at heart, I couldn't agree more with any of the all of the points that you have said about making people more interested in the moon. Thanks a lot again, and let's have a picture to close the session.
Thanks a lot to ILO and to ISRO for organizing this interesting GNF, and of course a big thanks to all the speakers and the moderators. So please give them another round of applause while they are getting their group photo here. We are breaking now for lunch, and I need to tell you that already 10 minutes ago the IP session has started, the second IP session on the 5th floor, so if you want to join that. Otherwise, we would welcome you back here at 14:30, at 2:30 sharp for the next GNF session. And at that time, also the technical sessions will restart again. Enjoy the lunch. See you later.
you.